Good morning, good afternoon, or good evening, depending where from in the world you are tuning in.
Welcome to the 5G Made Together conference, creating future with open ecosystems.
My name is Aleksandra Hečko-Ilonek. I'm a product manager at IS Wireless.
And I am Rafał Sanecki from the IS Wireless marketing team. Together, we will be your host today.
We have an exciting program for you today. We hope you will enjoy it and find it inspiring.
The organizer of the conference is IS Wireless, which develops and delivers 5G mobile networks in the Open RAN model. But of course, it's not only us today. We have support of great companies you will see later today. We have over 350 registered participants for the conference. That's amazing. Please use the chat window to say hello and where you're from.
The conference will consist of two parts. We'll start with a debate, and then a lineup of talks will follow. Regarding the housekeeping, in the second part, there will be an opportunity to ask questions. We welcome them via a chat window on YouTube. Without further ado, let us open the conference. We invite Sławomir Pietrzyk, CEO and co-founder of IS Wireless, to officially open up the conference.
Good morning. I am very pleased to be here for the opening of 5G Made Together conference. This is the first conference in Poland and probably the first in the region which addresses the process of creating and building 5G networks in a collaborative way, focusing on ecosystems and not individual players. The number of participants truly exceeded our expectations. We take it as a sign of interest and importance of the topic. Yes, ecosystems are important, as they bind partners who share the same values and the same interests. Without ecosystems, it would not be possible to build modern car, phone, or a computer. There is no other way also in 5G. As a consequence, this effort should pay off for many and not a few. Ecosystems bring diversity. Among us, there are various institutions, public and private, small and big, young and old, global and regional. This is the true diversity which has a great potential in enriching value chains, also in the telecom industry. This diversity also allows the customer to select the best solution, which is very important. Last but not least, by making things together and inviting many, we unleash the bottom-up creativity. Creativity is a true asset, especially in this region. People experience tough times in the past, and they are really able to think out of the box. We strongly believe in the potential that is hidden deep in the human creativity. We feel to be a catalyst of this movement, but the catalyst who is also a team player. This conference opens a series of events that we hope will spread all over the world. I sincerely hope you will enjoy today's debate and presentations of our speakers. Only together we can win. 5G can only be made together.
Thank you very much, Sławomir.
Our first speaker is Robert Kośla, the director of the Department of Cybersecurity from the Chancellery of the Prime Minister of Poland.
Mr. Kośla is responsible for continuing development of the national cybersecurity system, building secure cloud computing ecosystem in Poland, and supporting government plenipotentiary for cybersecurity and cybersecurity committee.
Mr. Kośla will talk about cybersecurity aspects in Open RAN. Mr. Kośla, the floor is yours.
We cannot hear you, Mr. Kośla.
Okay, good morning, everybody. I apologize.
Now it works, perfect.
And I would like to thank you very much for the invitation for this very important event. I believe this is one of the major steps actually in developing and strengthening our ecosystem for the 5G secure deployment across Europe. Of course, the topic for my today presentation is related to cybersecurity aspects in Open RAN, but it will be much broader overview, even in very short time frame that I got in this very full agenda. Of course, 5G cybersecurity background for Europe was set by a recommendation of European Commission in March 2019, when we all member states together with European Commission decided to invest more in future 5G and then next generation of mobile communications. And we set 3 key objectives. And one of those 3 objectives was related to standardization certification, the area where actually is still not well supported, at least across Europe. To achieve this goal, we decided within the NIS, so Network and Information Security Cooperation Group, there was a dedicated work stream developed, and this work stream focused on 5G and addressed the importance of the task related to certification standardization by assigning a special 5G subgroup. This subgroup was proposed by Poland and Germany and supported by other member states. So we started to work in parallel to ongoing efforts on the definition of the set of strategic, technical, and supporting measures that finally been published, approved and published by European Commission and member states in January 2020. Of course, this is, I believe, major steps towards cybersecurity, because it covers not only the legal, the governance topics that requires additional authority powers for regulators, but also calls directly for technical measures and supporting actions. So those supporting actions, supporting measures are related to standardization certification. That's why, of course, the key area for this 5G subgroup, co-chaired by Germany and Poland, was to support implementation of 5G toolbox with the efforts on identification where we are in standardization, covering, of course, and addressing, identifying all the processes for the technical specification development by industry, and the work that was initiated on the basis of ITU IMT 2020, efforts on the next generation of mobile communication, continued by 3GPP. Of course, when I talked about 5G toolbox, we need to refer to those 3 specific actions, the supporting actions referring to standardization. So, of course, the process that was proposed in parallel to implementation of Cybersecurity Act. I will remind that Cybersecurity Act agreed by member states in 2019. It was actually the act that was foundation for creation of European certification schemes. One of them, the first one, was EU Common Criteria Certification Scheme for components, and many components for the construction of mobile networks actually will be or are already evaluated against common criteria. The other aspects, of course, are to recognize and to identify the gaps in current standardization efforts and technical specification developments, how they address cybersecurity aspects. So that's why, of course, we need to identify the gaps. We need to propose some security measures from governance perspective, from public entities, and from regulators perspective. And finally, of course, this is the question of how we can combine those technical requirements with organizational measures that need to be implemented to really manage the risk across 5G networks, regardless of its proprietary solutions or open specification like Open RAN. Of course, identifying those standards, we created the mapping table, and this is a living document. So this job is continued. This is actually the snapshot from last year, from the end of last year, but actually capturing most of the developments from technical specifications on specific action, on specific layers of 5G. So of course, core network functions, visualizations, and other layers. We map them to technical specification by 3GPP. We map them also to existing evaluation schemes like those developed by GSMA, so again industry-led organization, GSMA focusing on NESA, so networking components evaluation and certification. So of course for the future work we do not start from the scratch. So it was as we mentioned this during the 5G subgroup meetings, the idea is to actually collect the low-hanging fruits, actually. So taking the components and do not reinvent the wheel, especially referring to existing technical specification, mapping the roadmap for development of specifications, and also to combine the future 5G evaluation scheme and based on the foundations from already developed schemes and the schemes that are under preparations. So what we reviewed within the 5G subgroup, and that's where we also started to discuss the questions related to diversification of the market, to the need to support the development of the market, also recognizing the interoperability and openness of the specifications. That's where we set the policy context for 5G certification in Europe. Of course, we fully recognize that certification can bring the value in reference to certain risk. Of course, certification is not a silver bullet, will not solve the problems, for instance, related to strategic measures like those related to high-risk vendors identification, because usually evaluation certification just confirm the correct implementation of the product, the target of evaluation in the process of evaluation of the products, and the targets are met by the product itself, or the product is compliant, or all the requirements covered in protection profile as a set of security requirements being correctly implemented in the product. What's more, of course, we wanted to address technical measures TM09 and 10 related to technical assurance of the networks. That's what was actually addressed in the call for EU-wide certification scheme. But the next step, and I think also very important for the development of interoperable interfaces and specification like Open RAN, it was defined by and published by European Commission in the document EU Cybersecurity Strategy for a Digital Decade. And it's actually one of the points that I highlighted here. It's securing 5G networks and supply chain for development and implementation and maintenance of 5G networks. I highlighted the point number 1.3. Of course, it's in the chapter of resilience, technological sovereignty, and leadership. Talking about sovereignty, it's a question, of course, how we can develop our European ecosystem to be capable to still develop and deliver secure components to implement 5G and next generation of networks. So, of course, in this document, in this strategic document, there was a statement about Commission will to work with member states and with ENISA to develop action plans for strengthening 5G security. And in this annex, in the annex covering the action plan, you can find three major objectives. The first one is related to ensuring national approaches, of course, to mitigate the risk across EU. So there where you can find the references to strategic measure of 03. So it's referred to high risk suppliers. You will find there also the reference to research made by BEREC, looking at the diversification of the market. In the key objective, in the second key objective, you will find, of course, knowledge building activities, and you see also the reference to the challenges with open architectures for 5G and development of the future features needed actually for the next scenarios where mobile networks will be very important. But the most important from my perspective and the topic for today's presentation is actually key objective 3. That's about promotion of supply chain resilience and other EU strategic security objectives. That's where you find the reference to standardization. That's where you find the reference to supply chain resiliency. That's where you find also reference to certification. So one of the goals one of the goals, especially standardization, was continued by us within 5G subgroup. But coming back to certification, of course, that's what I wanted to note. As you are probably aware that European Commission just submitted requests to ENISA to start development of 5G, EU-wide 5G certification scheme. On the left side, you see the slide from our subgroup, that actually there was a discussion how this scheme should be built. Of course, from some components of existing certification schemes, like those developed by industry, some components related to information security management, and also recognizing the secure identity and authentication that is necessary actually for this mobile ecosystem. So, of course, the first step regarding certification, the initiation of the scheme, the candidate scheme's development was made. So we could move to the second step that was related to standardization. So that's why one of the key action is to develop action plan on standardization, because there is a strong need for transparent forecast and mapping for the future standards. Of course, recognizing and a special attention to Open RAN. That's where we cover right now, developing the action plan for standardization for 5G. The draft for the 5G action plan on standardization and certificate development was presented by us last week. And this action plan includes two objectives. The first, so define a European 5G standards policy, how to identify and shape relevant standards, and we define specific steps with the engagement of ENISA, engagement of member states and experts coming from MNOs and coming from vendors. The second objective is accompany and support ENISA's 5G certification scheme development. So, of course, talking about ENISA, there is one project related to Open RAN. It's our Open RAN security deep dive. That was dedicated workshop on provided by ENISA in March. Next steps is actually identification analysis of the key issues, of course, benefits for the member states. And also right now there is ongoing process for identification and recommendations and actions. So as you see, also subgroup is engaged, ENISA and member states, and at the end of this year there will be a report for Network and Information Security Cooperation Group regarding Open RAN security. But of course, some challenges without financing. This is, I think, a little limited. So that's why, of course, we need to recognize how 5G security, how Open RAN initiative will be supported in Europe. So, of course, first, its delegation, its recognition by the EU Council conclusions referring to recovery and resiliency facility, recovery and resiliency funds. And there you can find directly this special percentage of allocation of the funds for secure network infrastructure, including, of course, 5G. Just one example, two examples from the national documents. On the left side, you can find a document published in Germany referring to development of open standards, Open RAN, and also the level of investments planned at the level of 2 billion of euros. In Germany. In Poland, we also included 5G development and implementation in our national recovery and resiliency plan. So you can find also topics related to 5G, both for implementation and development. And the last element, of course, is the partnership, because we have a lot of partners, industrial partners today during this event. So, of course, in Poland, we have dedicated program, PW Cyber, based on trust and security. It's open for companies from NATO and EU member states, and also countries that have security agreements with NATO. This program is about enhancing the awareness about security, about cyber threats, security baselines for the secure implementation of technologies, also referring to tests, assessment, and certification. Finally, and I think this is the good introduction for the next presentation, we have, as you see, not by accident, we have partners very strongly engaged in 5G ecosystem, also supporting Open RAN initiatives. And today, maybe that will be a little spoiled. Today will be later today there will be a signing ceremony at hub CyberMade in Poland, including more than 40 Polish companies. Among them, IS Wireless will join this agreement as well. So we will continue to support development of Open RAN architecture also very strongly in Poland. Thank you very much for your attention, and I would like to give the floor to the organizers. Thank you.
Thank you, Mr. Kośla. It was a great introduction to the debate, which is about to start now.
Indeed, let us move to the debate. It would be led by Petar Popowski, the professor from Aalborg University in Denmark.
Petar heads the section on connectivity at the Aalborg University and is a visiting excellence chair at the University of Bremen. He's a fellow of the IEEE. He received multiple grants and awards, including Technical Achievement Award from the IEEE Technical Committee on Smart Grid Communications, the Danish Telecommunication Prize, and William Investigator Grant.
Petar, the floor is yours.
We need like a few moments to organize the debate and dial in all participants, so we will be back in a few seconds.
Should we start? Okay, I believe we can start now. So thank you for inviting me to host this debate on Open RAN. We have four speakers. The first one is Franz Seiser, who is a vice president of access disaggregation in Deutsche Telekom. Then we have Zygmunt Lozinski, who is a senior technical staff member, master inventor, and quantum ambassador at IBM. Lorcan Berg, director of radio access networks at VMware. And last but not least, Sławomir Pietrzuk from AS Wireless. So I will start with following up the presentation of Mr. Kosla related to security and data privacy. So I would start with the question of security of components and data privacy. So the role of, as well as the role of Open RAN in private 5G networks. So there is a lot of discussion about the improved resilience of Open RAN and the improved security. On the other hand, in the 5G networks, we have a lot of discussion about the private 5G networks that are going to offer improved security. So how do you see these developments? What is the main argument for providing better security in 5G networks? So who would like to start? Maybe we start with Franz. Or Zygmunt? I'm just going step by step.
Yes, let me unmute. So the role of security. I think that what we're seeing is that around the world, everyone is focusing on security. So, for example, here in the United Kingdom, the government is just promoting a new telecommunications bill. And one of the things that bill includes is a set of obligations on operators about how they secure their networks. And it includes the requirement to implement best practice in terms of how sensitive functions are managed, how sensitive functions are accessed, how the assurance process works. And I think that has the potential to help both smaller operators and also potentially enterprise customers who are looking to deploy private networks, private 5G networks, because at least in the UK, there will be a baseline, a code of practice, which was developed by the National Cybersecurity Centre to say, after looking at all of the security threats, here's what we recommend everyone should do. And that code of practice is now available for everyone. So I think that idea and the things that Director Kozla was saying around how the NIS group are working, there is a lot of focus on security. And I think we should be optimistic about it because everybody's taking this seriously and putting a lot of work into it.
So, but one thing is the security, offering the security to the network. On the other hand, we need to have certain sharing of data across networks, especially if we want to train the networks to work in mission critical scenarios. So how do you see, is Open RAN facilitating this sharing of data, operational data that will basically help the network become better? I'm here thinking about various machine learning and AI algorithms, or you think that that would be better with the proprietary equipment?
If you're asking me, my observation is that the Open RAN RIC is a potential model for us to apply machine learning technology to improve the operation of the radio elements of the network, but that doesn't require any data to be shared between, for example, the different slice users of the network if we have 2 or 3 enterprise customers making use of that network. So I think that will work reasonably well, but we're going to have to test this as we build these networks out. We have to test to ensure that the security is in place.
Thank you. So let's move to the next question. That what are the major problems of traditional RAN that can be addressed by Open RAN? And we have heard about resilience of the supply chain, diversification, and so on. What would you highlight as a major problem, and what is the exemplar use case where Open RAN is offering a clear advantage over traditional RAN? So maybe Lorcan can take this question.
Yeah, sure, Petar, glad to. So I mean, I've worked over the years and built various sizes and shapes of radios and end-to-end systems, as has Mr. Burley on the call from Ofcom, right? So one of the problems with traditional OEMs is that they have to focus on their main market segments, right? So which usually means building, higher power radios traditionally for macro coverage. Problems there have then resulted in that if I need to do dense urban capacity delivery, I haven't really got radios that are suitable to deploy in street furniture or closer to customers, which would make it more efficient for delivery of capacity where it's really needed. And similarly for enterprise use cases, so indoors, classically still, we talk a bit about that private 5G case. There isn't really a lot of enterprise quality small cells still available since 3G, and even the residential use case. I mean, there's a lot of AT&T probably shipped 18 million residential small cells in 3G, but nobody was really willing to build the 4G versions, right? So that there's been a problem about delivery of capacity where it's actually needed and maximum view on how to deliver that. So one of the things I've worked a bit over the last couple of years with the telecom infrastructure project folks around how do we reassemble some of these components with the security parts in mind, with a range of RAN components and sizes and shapes of radios, and how do you build it in a way that it can sit in the ecosystems it needs to deliver? So whether it's a dense urban environment, making sure that cities have fiber in the right places, that there's street assets physically the right size and shape, and working in a community with the operators to get the right requests for where things should be built. So that sort of thing I think is actually enabled by Open RAN. And that's an area where I love to see people like IS Wireless building innovative radio solutions end to end, working with the ecosystem of different RAN vendors who interestingly enough, some of those radio components have been used by the larger OEMs over the years, but because of Open RAN, it's much easier to reassemble those. That gives us a different set of problems on system integration, driving costs down, release on release, that system engineering part. But I think that's an area of expertise that Europe has traditionally been quite strong at, right? How do you do system engineering? How do you manage requirements? How do you assemble things in scale? So I think that's an area from a community perspective we need to really focus on and drive our innovative partners in that ecosystem.
So you think that, so you're basically saying that there is a open space for customizable radio equipment, which it cannot be delivered by traditional RAN and can be done by mix and match of the Open RAN, I would say. Exactly,
and I think to the point on the likes of the RIC earlier on, right? So what we now at least have is the ability to open up some of the harder to manage parts of the radio infrastructure, like that people will talk about scheduler and how do you link, a higher order MIMO system with a digital unit. Because we have some more open interfaces, we can actually start doing that and start applying more agile software techniques to start fixing those problems. Which again, I think it just brings a broader community of people thinking on fixing those problems in a different way, which it's very hard to do if you're focused on building big products for the mainstream market.
Thank you. Somebody else wants to add something to this question?
Yeah, can you hear and see me now? Sorry, this is Brand here. I seem to have some issues.
Yes.
I hope it works now. So from the customer perspective, as I'm representing an operator here, of course, one of the key issues we have with traditional RAN is lock-in to one of very few suppliers which are offering this type of products and all the consequences out of it. Because simply once you have decided for a certain supplier, the way a RAN is constructed today, everything has to come from that supplier. There's simply no way to do a mix and match easily, and if you do it, it's very cumbersome. So you're completely dependent on the products they have, and as radio is a pretty complex beast, and the technology you need to have for radio units is very different than what you need to do for baseband. But still, you are totally dependent, and you are dependent on the type of products they offer, because there is no way to mix and match baseband and radio unit of different suppliers as of today in traditional. And that, of course, also leads to limits regarding speed of innovation and getting tailored products, because it's just rightfully said. Of course, if you're a big supplier, you focus on the most profitable mainstream market, and it's always a bit difficult then to have some niche solutions available. But if you don't, and you have that supplier, there's no way for us to deploy that kind of niche solutions unless we go for pretty complex setups. And that's exactly what we try to overcome by slicing the elephant, if you want to put it like that, in much smaller building blocks that can be delivered by much more specialized companies coming in with fresh ideas, because with lower hurdle of entries, there is a market evolving where there was no market before. Because if you had a bright idea in the area of radio up to now, either you managed that one of the big suppliers took it serious and put it into their product portfolio, or there was simply no market. And by putting that into these much modular schemes, there is much more opportunity to enter the market that immediately leads to a situation that new companies are coming up trying to address that. And as I look at it, there will be plenty of opportunity going forward for these kind of companies, which on the other end, of course, raises competition. Competition means more innovation. More innovation at the end means better product, which at the very end means a better product for the customer and better connectivity experience they can enjoy. So that's the whole line of thought, and that, of course, all run state of the art. Because yes, to come up with one of the concerns, opening up and putting it into more building blocks, of course, it raises complexity. Now, it's not a new complexity. The complexity had always been there, but up to now it has been handled one of the big suppliers with all the downsides. Now that becomes more visible to us as operators. And again, the only way to address that, and that's then again driving innovation, is putting automation and all these state-of-the-art technologies, as said, machine learning, AI, all these kind of things first in the design, to be sure that we can run that technology even better and even more efficient that we can run a traditional round today.
Thank you, Franz. So we can move to the next question now. You have mentioned the increasing complexity and relation to performance. I'm going to come to that in the next question. But first, let's look at in what other architectures that we are going. The radio architecture supported by Open RAN. For example, one thing that we can say that is that there will be ultra densification in 5G. There will be many more base stations. So in this way, we are going to improve the coverage. On the other hand, in the communication research community, we are seeing paradigms of massive MIMO, cell-free networks. You know, the traditional cellular architecture where we are partitioning the space in cells is being dissolved, basically. So we are coming to antennas which are covering a large region and collaborating to cover this region. So how is Open RAN related to this architectural development? So maybe Slavomir can take this.
Thank you. Can you hear me, by the way?
Yes.
Okay. So thank you for this question. Well, Open RAN allows you to realize flexibility, basically. So you can cover any of those cases because you have an embedded flexibility in the design. It's a flexibility by design. With highly granularized solution, you can build a macro network. You can also build high capacity network, and it's up to the needs of the network operator or the customer where we locate radio units, where we locate distributed units, centralized units, and what they will be. I mean, in terms of computing equipment, what kind of gear we will use there. Will it be dedicated hardware or maybe shared hardware? Actually, I would like to make a point here that we think that the near future will not give us a comfort of building a dedicated network infrastructure. We will reuse what is existing as much as possible. So I don't know how many of you do remember wooden telephone poles. They were used to carry cables, right? We don't see them anymore. But does that mean that cables disappeared? No, they are built along with the non-telecom infrastructure. Actually, we are using some other infrastructure like roads, pipes, to lay cables. And I think this will apply to both the locations, of course, so hence this idea of neutral host, but also to computing. And in many cases, we will have to live with the computing resources and front haul, mid haul resources as they are and adapt. Now, Open RAN gives you the flexibility because the monolith is partitioned into blocks that you can locate accordingly to the needs. And that's the beauty of Open RAN. So if you want to build a macro site, well, why not? If you want to build the dense urban, that's possible. And maybe last word on the massive MIMO thing. I think that this is a consequence of the fact that currently we still build networks according to this old model where site acquisition is very difficult and lengthy. So if we have those sites already acquired, then we want to use the most use of them. Therefore, we will equip them with all possible MIMO combinations with antennas and so on. But I'm more in favor of another view. Of course, this all is to increase capacity, capacity expressed per square meter, so area capacity of the network. But I think that the area capacity can be increased much larger by densifying the network, and that this is really the target. Of course, it's tougher because you need to have a front haul saturation, availability of front haul links in a much denser points, but if you combine it with this observation of using non-telecom infrastructure, I think that that's the only way to go to the future.
Yeah. But that's why I also asked what is more suitable. For example, if you take this view that we need to reuse computational resources, infrastructural resources, cables, and so on, then maybe densification and let's say that type of interconnection between the various access points would be more suitable. If you have cell-free networks which require very complex real-time signaling among the antennas, maybe they require a dedicated infrastructure. So maybe they are not the most suitable for this implementation that you are mentioning. Yes. So any other comment on this?
I mean, a small couple of things we did, and again, Simon will be familiar with this, right? So SoftBank in Japan has probably got 300,000 macro sites in the same physical area that London has for 15,000 macro sites. So you can imagine that the problem there is that you just don't have enough physical sites to deliver the capacity that delivers a good enough experience in some of these major cities. So one of the things we've done over the last couple of years, again, with the TIP community and the solution group, is look at how do we bring cities and operators together to pre-plan a number of those assets. And that's everything from transmission assets, the variety of front haul assets, what the city needs, what the operator needs. Can we reuse existing street light assets, everything, and existing physical data centers or more regional data centers, street cabinets, bins, bus stops. So part of that is getting blueprinted at the moment, just in terms of how to bring communities together, because I think Petra's point on the traditional site acquisition doesn't really work anymore. In the case in Dublin, there is no physical macro site capacity left. So minimum for the next year, I need another 100 street level sites for so we did a bunch of radio and capacity planning with the city and the operators, and there's at least 100 street level sites needed in the middle of the city, in the main shopping areas. So we don't work together to get those built. Every operator comes asking, it just gets confusing. Planning permission gets delayed and rejected, and nobody gets what they need. So there's, I think a lot of this kind of, and that's why I love the theme of this conference, right? We have to build this stuff together, right? This 5G will be made together with our communities, a bit like the EU quadruple helix thing, right? We need our academic communities working with our citizens and cities and government with business to make this happen. Otherwise, it never scales, right?
Yeah, if I may build quickly on that one, Franz, here exactly the beauty of Open RAN comes into play, because one of the key design criteria is hardware-software separation. So whatever type of hardware has been built or is going to be built, it can be used then by the software ecosystem sitting on top of it, coming from Open RAN and ORAN, and develop, assuming you have the right hardware and you have fiber to the cells with sufficient bandwidth and low enough latency, moving from a classical network to a cell-feed network basically is a software update and not complex reconstruction anymore, because the hardware is there and you have separated your software layer from the hardware layer. So going forward in that way is much closer to what we know today from the cloud environment, that many even fundamental changes are a simple software, you get me right. It's a software update, yeah? So we move the whole radio as well to a software world with all the flexibility and speed of innovation and opportunities you get by doing that. And that's one of the key levers that Open RAN will deliver.
Yeah, but there is a strong assumption there that we have latency, which is very low to do this control, and that's a strong assumption.
Well, in dense urban, I don't think it's such a big assumption, because it's mainly driven by distance, and in dense urban, that shouldn't be an issue. Rural, of course, I agree. Things become more difficult, true. But there you may have not these massive capacity demands on the other hand.
But my point here in this question was that I'm not advocating any specific architecture. I'm just trying to understand which one is more suitable for the approach of Open RAN. And obviously, the densification and deploying more access points would be the preferred way. This is what I can hear from the discussion, rather than because the deploying of the new paradigm, like cell-free networks, is conditioned on very real-time, low latency, reliable control infrastructure. On the other hand, the other one can live maybe with more looser requirements. That's what I could get from this discussion. Because Pavomir mentioned opportunistic computation. That would mean that you are taking some computational resources which are lying around, but there is no guarantee. So you just look for a statistical effect that if there are many of them lying around, you're going to get some performance. Right?
You may have non-deterministic and you may have deterministic capacities available. Why not? I mean, imagine that cloud resources that are shared will be shared closer to the end user, and you can call them edge resources, shared edge resources, and that they are perfectly suitable for making these real-time operations if they are needed.
Yeah.
And to the point of reusing a little bit, Petar, right? So I've in the context of some of the research activities I've got going on, which everyone here is happy to come and participate or observe, right? I've been putting compute in street poles, on street poles, looking at different radio and RAN splits, what's cost effective, what that does to the radio head cost, right? Because the flexibility required in the radio head means I have to keep it in FPGA at the moment, which means it's more expensive. So I get the flexibility, but it costs me more. So how does that work from an economic model perspective? And then how do you reutilize people's street cabinets, traffic light control systems? There's physical edge all over the place. Some of it's suitable for compute, some of it's not. And some of it depends a little if you're a traditional mobile operator that does not have a fixed fiber infrastructure, a bit like Deutsche Telekom in Germany, right? A big advantage in that. If I'm a new entrant traditional mobile operator that doesn't have a good transmission network, then latency becomes quite a big debate, and the cost of transmission becomes a big debate. So there are some trade-offs that will push the edge to some other places and push the ability to reuse, right? And physical asset and co-location space become quite critical in that.
Yes. Thank you. So we move to the next question. We are always mentioning the keyword of 5G here, but most of the time we're using non-3GPP technologies like Wi-Fi, right? And the question is, what is the role? How do you see the role of these non-3GPP technologies within the whole ecosystem of new radio access networks. For example, one is Wi-Fi, but the others are many proprietary standards for IoT, like Sigfox, LoRaWAN.
Yeah.
And there are also, we are talking about non-terrestrial technologies now. There are LEO satellites, for example, which are now turned to be using the 5G technology, but there are other satellites which can provide, like geo satellites, that can provide certain backbone. Like we had the development of the heterogeneous networks on the terrestrial side. Now we might have something similar in the space side. So what is your view on the relationship of the core 5G with the non-3GPP technologies in this Open RAN? So who is going to take this?
I mean, I know it's a bit boring. I can have another go on that one, right? So the Wi-Fi is definitely not going away. It's probably in real data yield terms the highest amount of throughput delivered over Wi-Fi. So it isn't going away, right? I think it's the primary use in the home has increased a lot, right? And often in residential cases, it is difficult to deliver licensed radio coverage indoors, right? So there's still a role for that. I think better integration and control of quality for the mobile service as it's delivered over Wi-Fi becomes more important. So once again, with the TIP folks, we've done some experiments on mobile data offload to Wi-Fi, but measuring quality as to whether it should be offloaded as opposed to the current, voice over Wi-Fi, which is a little bit unpredictable still. I mean, it's adequate if you sit next to your Wi-Fi access point, but it's not good if you want to wander around your home doing stuff, right? So I think it's getting increasingly important to figure out how we link them. In an enterprise case, every time I talk to a large enterprise about private 5G, they say, will it look like Wi-Fi when I manage it, right? So I think that in a lot of market segments, the need to have a closer alignment is still there, and I'm not entirely sure we've addressed it as an industry yet.
Yeah, thank you. So let me go to we have been talking about the advantages. Let's talk about some challenges of wide deployment of Open RAN. For example, there is a lot of analogy made to the internet development. Why internet was a big success in the 90s and started to proliferate. The reason was mainly architectural, right? Because there was a good architecture that allowed very distributed deployment of modules, protocols, and so on. And then, on the other hand, we know that when we develop in that way with a good architecture, in many cases, performance suffers, or at least the performance has to pick up after some time. So in terms of, for example, latency and timing guarantees, if we have Open RAN, we are having a cascade of blocks by different vendors, and the end-to-end latency is difficult to control compared to the case of a single vendor that provides all the modules. This is is a physical law. So so that is one challenge in terms of performance and latency and maybe reliability. Then also the issue of patents with in 3GPP and in other standardization. So how do you see, what are the main challenges you see for the wide deployment of Open RAN, in addition to these two maybe? Or maybe you can comment these two. So maybe Zygmunt can start on this.
Sure. So I'd actually argue that the most important thing is going to be, in order to you need to guarantee repeatability. And in order to do that, it's important that we use automation so that we have standard deployment patterns and we replicate them, and so that we don't have different configurations of elements, different configurations of nodes, but the ones that we know work are deployed the same way every time. And there's a second area I think that's important, that's skills. We're going to have to address across Europe and across the US, the requirement to have more people with skills both in the end-to-end design of networks and the underlying cloud technologies that they sit on top of. And then I think the third element is going to be multi-vendor interoperability. How do we do the certification? And there's a role for test beds so that we can actually demonstrate that these things work together, because operators are going to want some confidence that they're not the first person trying out vendors A, B, and C, whereas they know A, B, and D works. So those are the points that certainly I'm focusing on.
Other comments on this? Thank you, Zygmunt. On the, for example, the latency and the timing guarantees, which is critical in open systems.
Yeah, to build on that, first of all, I totally agree. Probably the biggest challenge is not technology, but skills and mindset. Because as I'm running the endeavor in Deutsche Telekom, I can tell you, typically you either find people who are real radio experts, they can tell you everything about the air interface and much more, or you find people that are really good in compute. But just to make sure that these guys can start to talk to each other is a challenge as it's in itself, because these are two completely different worlds, and now bringing people over the border to start to understand the implication and what it means is one of the key things. Plus, as said before, if the complexity becomes more visible to us as operators, we of course also need to be able to deal with that complexity. And these are skills, as said today, this has been done by suppliers. Building up that skills, that understanding is quite an issue. But without that, it doesn't help if you have the proper technology if you're not able to build and operate. So building that skill in parallel is absolutely key. Not sure I can follow your latency argument, by the way, because just we build Open RAN, the basic building blocks, as long as we talk about 3GPP compliant technologies, are not changing. Yes, they may come from different suppliers, so you need to invest in putting the right SLAs in place. But what you also need, and that's also seconding what just has been said, of course, we don't want to start from scratch in our lab. So if we build an end-to-end change with multiple suppliers, of course, we would very much appreciate and even assume these suppliers have worked together already, have done some fundamental interworking tests. So I know when I put these two components, they're working. One of the means, of course, we are building and pushing a lot is having certification, similar to how you today certify devices that they work with the fully that develop and goes forward in providing the certification. So I basically know if I put the things together, I don't know, there's somewhere at 80% of what can be reached, and I only need then to fine tune to my specific deployment scenarios to really get the same level of performance, because that's a prerequisite. In the end, the ORAN system must work at least as good as a classical system I can buy today. Because I still need to explain to my finance guys why I should spend more money, and now I have an open system. It's hard to explain. Of course, it has to deliver on the performance as well as on the commercial side. So one thing we haven't touched yet. Of course, at the end of the day, the TCO of an Open RAN system cannot be 20% more compared to a traditional radio, because I think all of you are aware, radio is the biggest single most spending block in a mobile network. So there is no way to accept higher prices in that area. And I think it can be done. Yeah, I think it can be done if we put the right levers.
Just to clarify a bit about the latency argument, I was at another debate where the vice president of ORAN was there, and also we had the same question. She said that, of course, it's impossible to give the same latency guarantees as a single vendor, simply because there are more blocks involved. The point is that, as you also know well, scheduler for many years have been the differentiator between different vendors, right? So how they are scheduling resources with multiple users. The point is that the scheduler is a differentiator because it controls the resources, which are allocated to specific users. And the point is that if you have an open RAN, you are not sure that is going to conform to the best algorithm you have. So it's just there is uncertainty. But on the other hand, what is claimed by Open RAN Alliance is that maybe for a single link you can never beat a vendor, but for a scale of links there could be a significant advantage.
Exactly.
That's another point. So So I think we should really tell the things as they are, because if you have control over all blocks, theoretically it's impossible to beat that. Right. So I think we are running out of time, and maybe for the last as a last question, who will be the integrators, and how will be this deployment? And as well, we have heard several times the argument that the things which are there will not go away. So in the same way, the traditional RAN technology will not disappear tomorrow. So the point is that who is going to do the integration, and how they're going to coexist with a traditional RAN technology. So who could comment on this point?
Well, I can comment. Actually, I think this question relates quite nicely with the previous one, because that's also a challenge that we are facing. I think the first tier challenge, which is finding our own roles in this ecosystem. Yeah. We are creating an ecosystem, and there are multiple players. Some are big, some are small, some are more ambitious, some are less ambitious. I think it's very important that we will be able to listen to each other and identify those that have potential to be integrators, and also those that have potential of take other roles, because there will be other roles for sure. Now, I think that in essence, anybody can be an integrator that has experience and means to be involved in a multi-domain operation, I would say, because this is what the integrator is about. So, of course, this can be one of the telcos. This can be as well one of the hardware providers, computing hardware providers. This can be many other players. I think that there is no single answer who should be that, who should take that role. And my strong belief is that in a natural way of free competition and collaboration, co-opetition, there will be integrators emerging.
Okay. So you think that there will be dedicated integrators dealing with Open RAN technology from various vendors, various suppliers?
I think that there will be various companies trying to play that role. Some will be successful, some will be unsuccessful, and we will see after a while. And that is one of the challenges that we are facing, actually.
Thank you very much, Slawomir, and thank you, everybody. It's time to end the debate. I think we had some very good points. We have learned more about the position of Open RAN versus traditional RAN, and I hope they are very important takeaway points with respect to security, scale, and deployment. Thank you very much.
Thanks, Petar.
Thank you.
Thank you very much.
Awesome. Thank you, Petar, for leading the debate, and thank you to all participants. Now, let's move to the next part, the conference part.
Our first speaker is Artur Chmielewski. Artur is a senior sales executive at IS Wireless.
Artur is in charge of business development and sales. He is also managing the contacts with institutions and partners. During his more than 20 years of his career, he held various positions at companies like Avaya, Nokia, or Siemens.
Artur will tell us about Open RAN Wave 2. Artur, over to you.
Thank you, Mrs. and Mr. Chairman, for the introduction. Yes, I have the pleasure and the honor actually to kick off the presentation part of our event. As already said, I'm going to tell you about the next wave of Open RAN. We call it Wave 2.0, where we as ISYS, we are playing the role. I will tell you why it is important to have the next wave and what is the role of the ecosystem there. Let's start first from the first wave, as maybe not everybody knows what are the waves and what is basically the Open RAN. So the Open RAN Wave 1 actually focused on basically to solve two issues. The first one was the hardware and software disaggregation, separation, so that we can use the commercial of the shelf hardware and be ready for cloud. Actually, at IS Wireless, we took it as a starting point. So for us, it was no-brainer. So we are thinking, what are the other issues which are important, actually, to develop the modern mobile networks? And we identified three areas. The first is the software flexibility, which is reached by highly granularized RAN software. The another area is cybersecurity. And the last one, but not least, is ultra-dense network. Because we believe in order to fulfill all the 5G promises, considering the traffic growth, we have to go for densification. This is solution from IS Wireless. So we can provide a complete network. Even if we focus on RAN solutions, we can also deliver core. We have our MANO. But already on this picture, you see different use cases. We have rural, we have suburban, urban, and we have dense urban. And you have different components, actually. And for those different scenarios, you need different applications. You need different way to handle that. The next slide is showing another use cases. So we speak also about the industry. So you see that the number of dimensions is growing. It's not only the mobile public network, it's also industrial, Industry 4.0, which is another use case. But even Industry 4.0 is very generic. There's a different use case for mining, or for chemical industry, or for transport, or automotive. So you see there is a lot of use cases and a lot of deployment environment, and all the things have to be handled by the solution. That's why some years ago, while we started architecturing actually our software, we are thinking how to make it flexible. And the way we realized that is that the stack, the software which is operating the radio access network, can be composed of the separate building blocks. And actually, you can build whatever configuration possible, because you need different configurations and different scenarios. So it's not only about the DU and CU, which is defined by 3GPP, but it's also the way how the software can be installed on those machines. Because you will have to use in the future also the existing computers and existing transmission. This is what was mentioned during the debate. We will not be always able to add more computing power, to add more transmission capacity. So we have to be smart, we have to be flexible to handle all those different use cases. So let me visualize it a little bit better. So with our flexible stack, you can build whatever solution, but let's start from two extremes. So on the top, we have the centralized. Actually, that everything is moved to the center. It could be, of course, deployed in the cloud. And you can benefit from actually having the resources centralized so that you don't need to have so many instances. You can handle more of your network with actually less software. And you can have another extreme. So actually that you put all the stack into the radio unit, which is actually becoming the integrated radio unit, the distributed unit and the centralized unit. So we speak about, we are moving to the edge of the customer, or we speak about the small cell concept. And then basically you can have everything in between. This is just an example which is very much promoted by by Oran. So we have a split 7-2 between radio unit and distributed unit, and we have split 2 between distributed unit and centralized unit. This is what the majority of the Wave 1 vendors can deliver today. But you can imagine different scenario. I mean, it may happen that you have to use the existing computing capacity which is available on the local host. This could be so-called neutral host. So the host which is available, which is rented from somebody else. And then you have to be ready that if this host does not have enough computing power, that you lower actually, so you upload only the piece of the software, whereas the rest is again centralized. Of course, you have to have then the good transmission resources between the DU and CU, but you can do it actually. Moreover, you can even do it in a dynamic way. So let's imagine the situation that you have your piece of RAN is actually handling the office area. So you have a lot of traffic actually and during the working hours, and you have your DU, but actually the capacity is not enough actually to handle most of the traffic. That's why you have to have the rest of the stock and the central unit maybe somewhere in the cloud. And now, after hours, you don't need anymore these resources because the traffic is going a little bit low. So what you can do, you can transfer actually the part of the stack to the DU and offload the capacity, the computing power from the cloud. Or you can even shut down the server if this is on your premises, or you can bring it back to the pool and use it for something else. You can do it dynamically. And then in the night, where the traffic the traffic is really low, you can transfer everything actually to the DU and to make the DU-CU actually making this element acting as a DU-CU and completely offload the cloud resources. Or if this is your instance, you can shut down and you can save the electricity power on that. So this brings the flexibility. Actually, in order to build that solution, which is so flexible, you have to assemble it from many different components. And actually that brings me to the ecosystem and to the way the ecosystem plays. Because you see a lot of different areas. I'm pretty sure that maybe the slide is not even mentioning all of them, but at least let's focus on the major of them. You will see today also the presenters coming from companies addressing this or the other area, the other domain. We as ISWS, we are focusing around. But this ecosystem creates, first of all, creates innovation. So everybody is focusing on its own expertise, on its own area, and actually is delivering the best he can in order to serve particular network demands. There is also increased competition, actually, which reduces the cost. And moreover, the ecosystem means also that we are partnering. This is a kind of co-petition, as Slavek mentioned during the debate. The co-petition means that we are partnering with our colleagues, I mean, covering different ideas, and do also the integrations. Already do integrations with and covering different scenarios. And this can reduce also the integration burden in the future. So the ecosystem is really a powerful idea. And I have to say, it's not always followed, because even some of the Open RAN players today, they rather try to silo the solution. So they speak just to one selected RU vendor, and actually they are building the same what was in the past, but it's just this disaggregated software. Is it the solution we want to have? No, rather not. When we speak about assembling the solution, then of course the cybersecurity is becoming an important issue. So today our solution, at least, has to cover a lot of security concerns. The security defined by 3GPP, defined by ORAN, defined by ETSI when it comes, for example, to virtualization. This is covered, actually. This is covered by the solution, but this is so-called horizontal security. We also have to investigate the vertical security, because the solution is composed of from different elements, and we have to make sure that this is secured. This is important, actually, but this is also not that complex, because a lot of that products, actually, or solutions, where we are putting together and assembling the one solution, has already some kind of security inbuilt, because they are used for different purpose. We just need to make sure that this solution is carrying over, that this solution is actually covering all the needs of the modern networks. And by the way, we are just kicking off the project with a few Polish state institutions, actually, to focus on this vertical security. And actually that brings me to the last topic, which is the densification. Densification is important. And let me show you the analogy here. So if you really want to read a book, you cannot just rely on one street light, which is providing you light during the night and standing on the street. You need many of them. You need also, most likely, you need your own at home. That's why we cannot just rely, if I bring this analogy further, we cannot just rely on the macro. We have to start thinking about densification. This is the key to success. Some months ago, we did an exercise. So we modeled actually the Poland and the existing mobile network infrastructure. And considering the traffic growth, actually, and everything what 5G is going to bring, we found the conclusion that even utilizing all frequencies which are at disposal, we will need to build another, we actually need to double the number of sites. Of course, this example, I'm sure, is the same for many other countries. It's valid also for other countries. Maybe not exactly dependent on the traffic growth and the traffic prognosis, but in fact, we will have to build a lot of new sites. And this cannot be built, actually, the way it is built right now, because it's going to be too expensive. That's why we have to focus on two things. So we have to have the flexible software, which is utilizing the existing equipment and existing transmission resources. And we have to use additional intelligence, which is actually inbuilt in another piece of software, which is called RIC, so RAN Intelligent Controller, which is also part of our solution. Because with RIC, you can actually handle the interferences. We are speaking about something which is called soul-free, actually. And this helps you to increase the spectral efficiency and to get as much as possible from the existing infrastructure. So you don't need to actually build maybe so many sites as it should be, considering the classical approach. Let me then summarize. Rakuten Mobile, which was the first actually the first operator decided to go for Open RAN. Of course, at that time, that was just the Open RAN Wave 2. But they already claim today that they reach actually 30 up to 40% of savings in CapEx and OpEx versus the traditional deployment. Wave 2 is expected to bring another 20 or 30% because of the flexibility, because of avoiding, let's say, over-dimensioning and to use the resources and to limit the power consumption. The cybersecurity, which is also improving the network resilience. And the last but not least, the densification with the intelligence actually sitting on the RIP algorithm. And this is the last slide of my presentation. Actually, I used to play hockey with my kids and my friends in the past. And I know that hockey is a very dynamic game. So when I joined ICE Wireless, I saw this statement on many slides. And this statement happened to be a motto, actually, of the company. So this rang a bell at that time in my head. So I knew that I am in the right place because we are in a very dynamic reality. So we have to think, we have to be prepared for the future, not just focus what we need to do now. Thank you very much. I hope you enjoyed that.
Thank you very much, Artur. It was a great presentation. Do we have any questions to Artur?
Yes, so we have one question from the audience. The dynamic allocation of stack layers functions is extremely complex process and also processing time consuming. How will be in practice ensured guaranteed the quality of service needed for different users?
Actually, it's a very good question. I even didn't mention that. But the software is so flexible that actually you can have on one DU, you can have a different instances, so different portion of stack. And by that, you can separate the users. So for one user, let's call it the user which is, for example, the IoT or massive machine type communication. You need very specific requirements, but it's not very much traffic demanding. So you can put less on the same DU, and then you have another extreme. We have ultra fast and ultra reliable connection. You need more stack, so we can put it on the same machine and actually to distinguish between those two users and to satisfy completely different. Points of the 5G triangle. So slicing is so easy to make it with this kind of software architecture, we say.
Excellent. Thank you, Artur, for the answer. Let us move to the next speaker, Simon Burley, a principal of emerging technology at Ofcom.
With a career spanning over 20 years, working for RAN infrastructure providers and a mobile operator, Simon's expertise covers the architectural vision, design, and deployment of all leading radio access technologies. He now leads the technology work streams on vendor diversification within Ofcom, which includes the Smart RAN Open Network Interoperability Center, a joint program of work with the Digital Catapult.
Simon will tell us about open networks and vendor diversification in the UK. Simon, the floor is yours.
We can't hear you, Simon.
I'm Simon Burley, and I'm here representing the emerging technology team here in Ofcom. And for those of you who may not be aware, Ofcom is the UK's independent regulator for communication services. And today I'm going to be talking about open networks and the role that they can play in order to be able to diversify the RAN vendor supply base within the UK. So the presentation this morning will essentially cover 6 areas. So first of all, I'll give a very brief introduction to Ofcom and the work that we are doing within the emerging technology team. We'll then go on to give a very sort of brief history of how the RAN vendor market has consolidated over the last 15 or more years. And we'll see then how that has then led to the UK government publishing a 5G supply chain diversity strategy at the end of last year. So within that strategy, Open RAN is called out specifically. And before we go on to look at the work that we're currently doing within Ofcom, we look at some of the potential and also some of the challenges that Open RAN as a technology can provide us. So as part of the work within Ofcom, I will also be covering the Smart RAN Open Network Interoperability Centre. So Ofcom, as I've already mentioned, is a government-approved regulatory and competition authority for broadcasting, telecommunications and postal industries. So within this, we have a duty to represent the interests of citizens and consumers through promoting competition and encouraging investment and innovation. So within the emerging technology team within Ofcom, we are essentially responsible for tracking and monitoring the key and disruptive technologies that are on the horizon, and to try and understand how they can impact the citizens and consumers of the UK, and also the benefits that they can provide, and how we also may need to then modify the way in which we regulate the communication services as a result of that. So RAN vendor consolidation. So over the last 15 or more years, the RAN vendor space has seen an awful lot of change. So owing to combinations of market entries and exits through to mergers and acquisitions, we've witnessed a significant consolidation in the number of RAN vendors who provide RAN equipment for nationwide mobile network providers. And so also from the UK market specifically, this problem has been further compounded by government intervention and the setting out of a roadmap that will require the complete removal of high-risk vendor equipment from the UK's 5G networks. And as a result, operators now have a very limited choice when selecting the RAN equipment and service suppliers for their nationwide mobile network build-outs. So the UK government actually published its 5G supply chain diversification strategy last November. And this strategy sets out a targeted and ambitious plan to diversify the global telecoms market supply, and essentially focuses on three key areas of activity. First of all, it's a case of supporting the incumbent suppliers. So whilst we appreciate that there are only a handful of suppliers from which mobile network operators can choose from today, we need to ensure that their resilience and their ability to supply the market in the near term continues to be healthy. And also, as part of this process, we all need to be able to support their transition into an emerging market structure. Secondly, it calls out the need to attract new suppliers into the UK market. And this is essentially there to build resilience and competition, whilst also prioritising deployments that are in line with the longer term vision that the government has set out within the strategy. And then thirdly, it's a case of accelerating open interface solutions and deployment, so that in the future we're no longer reliant on any single vendor, and we can also begin to realise a longer-term vision for more open and innovative market. And of course, in the strategy, it is also called out that the UK actually accounts for only around 2% of the global RAN infrastructure sort of global revenues. And as a result, it is acknowledged that that partnerships will be critical in order to be able to create scale and also opportunities for new entrants within the RAN market space. So what are the potentials for Open RAN? So as I mentioned earlier on, Open RAN is one of those themes that is called out explicitly within the diversification strategy that the government set out. And so first of all, in there, it talks about open interfaces. And so, this is deemed as an opportunity to open up the market to new entrants and also provide a vehicle to be able to increase innovation and also drive down costs as well for both CapEx and OpEx as well for network providers. So one of the key themes that the industry is obviously taking to at the moment is the notion of Open RAN, and this has been led by the O-RAN Alliance, which was established back in February of 2018. And basically, they are looking to drive the industry towards more open, intelligent, and fully interoperable mobile networks. Now, of course, since it was only established back in 2018, the industry is sort of aware that that there is a period where Open RAN as a technology needs to gather some pace and start to provide capabilities that are in line with what the incumbent providers that already provide. And obviously their equipment is based on specifications that have been developed over a period of 20 years. So when you start to talk about new architectural frameworks and disaggregation of network elements, etc., then the process of putting the specifications to be able to design and deploy those types of network architectures, there is a period where where the maturity of Open RAN will obviously lag behind those incumbent vendors. So basically, as some of the work that we're doing within Ofcom, we are very keen to monitor the status and also the progress of the specification activities and also the vendor support for these specifications as well. And it's also important as well to try and identify the current and future use cases and deployment scenarios where Open RAN will provide opportunities for operators to introduce new suppliers into their networks. So we really are trying to understand, what are the key points, key opportunities in both the sort of technology and also in terms of timelines as well as to where those opportunities may reside and what form the introduction of those new suppliers may take in terms of introducing them into the networks. But of course, all of this is very good to sort of understand on paper, but we are actually also interested in testbeds and trials because we believe that they are actually key to proving Open RAN as a technology. And also as well, we also need to go beyond sort of the basic sort of interoperability testing and also look towards more performance related testing and also more challenging environments as well. So it's once we've sort of established how the interoperability of this as a technology, we need to look to see how we can then make sure that it will meet the operators and also other more generally network providers expectations and capabilities that they need to be able to deploy in their networks. But also building these sort of test beds and trials capabilities will also allow an opportunity for new suppliers to participate in the UK ecosystem, and therefore, with the aim of being able to then build a pathway towards operational environments and bringing in innovation to UK networks at a much faster pace. So, given the government intervention and the way in which Open RAN is building momentum within the industry, within Ofcom, we've actually set out a programme of work that, with the intention of looking at, the various strands associated with telecoms vendor diversification. So what we're doing is building up and developing the analysis, and we're also working with government, industry, and other stakeholders on measures to improve vendor diversity and encourage the development of open, interoperable ecosystems. So within this programme of work, basically can be broken down into around 8 sort of basic strands of work. 4 of those are associated with the technology assessment that we are currently doing within the emerging technology team. And here we are looking at the standards to see how the various O-RAN Alliance specifications are shaping up. We're also looking at the technologies, so understanding roadmaps and also, capabilities such as when, massive MIMO is going to be a capability that can be delivered to operators. We're also interested in the architectural aspects as well, so understanding the possible migration paths that operators can take in terms of, starting to bring in a disaggregated architectural framework within their networks and the paths that they may take in order to be able to achieve that. Of course, one of the key factors that led to some of the interventions from the government was associated with security. That is obviously also a very important thread of work that is ongoing within Ofcom. And of course, we need to understand, with the government intervention and the various bills that are currently being sort of going through our Parliament, we need to understand what sort of some of the policy implications are associated with that. And as I mentioned earlier on as well, we recognise that the RAN infrastructure space within the UK consumes only around about 2% of the global revenues. So we need to basically build up those partnerships with other regulatory bodies around the globe in order to be able to ensure that we're all on the same page and we can see, share learnings with each other to understand how Open RAN and also more generally open interface-based solutions can help diversify the telecommunications supply chain. And of course, we're also interested in some of the economical impacts of what is going on. I mean, within the UK, operators are currently rolling out their 5G networks. There has very recently been an auction for more 5G spectrum. There is the need to remove HRV equipment from their networks by 2027. So there are an awful lot of moving parts from a techno-economical perspective. We need to understand what are the implications that may have on mobile network operators, and also the potential impacts that it may have on our consumers and citizens. And then finally, the one which I want to call out here is also the test beds and trials, because I'll go on to speak about that in a little bit more detail in the coming slides. But as I've already mentioned, test beds and trials, we believe is key for us to be able to understand, the reality of Open RAN as a technology. And we also want to be able to take a walk in the operator's shoes to understand what are some of the key integration challenges and interoperability challenges they could potentially face, and to also experiment as well to see how the performance compares to legacy or your traditional sort of monolithic RAN solutions. So the test bed that we are currently building is called the Smart RAN Open Network Interoperability Center, or Sonic Labs, as we call it. And this is basically a collection of labs that is being jointly developed between Digital Catapult and Ofcom. And this is a 5-year DCMS funded activity that will launch next month. The Sonic Labs will span across multiple locations, giving the opportunity to experiment with disaggregated networks, where the initial focus will be on 5G Open RAN. The Sonic Labs will provide a unique opportunity for UK-based companies to get involved and to demonstrate their capabilities and their innovation. And for us, it will provide us that opportunity to get that first-hand direct evaluation of the reality of Open RAN. So the Sonic Labs implementation will we will be launching the lab environments next month. And at the moment, the labs will span over 3 locations. And over time, this will create a foundation for a broader national trials and testbed initiative that will also include aspects associated with fixed, core and transport domains. So at the moment, the focus is primarily on the RAN, but we will be looking to build out that capability. So as I've already mentioned, the labs will initially launch over 3 different sites. So there will be 2 sites will be hosted by the Digital Catapult, one in London and one in Brighton. And then within Ofcom, in our London office, we'll be also establishing the first lab in the Riverside House office in London. So the labs will initially launch with 9 vendors to start with, but we are gradually building up a pipeline to see which other suppliers that are showing interest. We're building a pipeline so that we can start to introduce them into the lab environment once it is launched. So in terms of the locations and timelines, so on this chart, I give a view of the components that will be hosted by the 2 parties, so the Digital Catapult and ourselves, Ofcom. So you can see that we have a range of CU, DU, and RU sort of combinations that will be considered during the course of the Sonic program. And whilst these are the sort of the way in which the suppliers will be sort of hosted across the two sites at launch, there will obviously be a plan to basically then to start to interchange the various elements within the Open RAN chains that we'll be building, and to understand what interoperability challenges will be faced when you start to build networks that comprise suppliers comprise different suppliers providing different elements within the network. So basically, the Sonic program, or the Sonic Labs program rather, will be completed in two phases. So we're currently in phase one, where we're coming to the end of the build process, and we'll start the operation of the labs when we launch next month. But beyond that, we'll also be looking at indoor and outdoor environments in phase two of the project, and we're already starting the planning for the build out of those two environments. I should add that in phase one, we'll be dealing exclusively with 5G standalone architecture. This is primarily due to speed in terms of being able to get the capability up and running, and also it speeds up the process of being able to acquire test licenses, etc., to be able to operate in just one spectrum band as opposed to potentially two or more if you're dealing with a non-standalone architecture. However, in phase two, we will be looking to build out that capability to go beyond 5G standalone and looking at bringing in a 4G and 5G standalone architecture as well. I should also add as well that that Sonic will form part of a broader lab capability that we're building within Ofcom, and here we'll be able to examine and experiment with the new immersive services and technologies like those that were covered in the recently published Technology Futures report. That it would allow us to be able to sort of test a range of use cases where new service types, etc., can be delivered within a mobile environment. So that essentially brings me to the end of my talk. So thank you very much for listening. And I just would like to add that we do very much welcome for you to please come and join us on June the 24th, where we'll be launching the Sonic Labs with a webinar starting at 10 a.m. UK time on the Thursday, the 24th of June. Registration closes on the 23rd, so we do very much welcome would welcome you to come along and get further details on the Sonic Labs and the journey that we're about to embark on. So that concludes my presentation. Thank you very much for listening.
Thank you very much, Simon, for your presentation. Let's move to questions right now, but before we do it, let me use this opportunity to tell everybody that we will be sharing presentations from today's conference to all registered participants, so no worries if you miss something. Okay, so let's move to questions.
We are up against the clock, but we have one question from the audience. You have mentioned trials in challenging environments. Can you give examples what Ofcom considers as challenging environment?
Yes, so we'll be looking at in an outdoor environment. So one of the potential opportunities that we have is to build an outdoor environment in London. So in a dense urban environment where there's a lot of clutter, etc. So that is sort of more akin to some of the the challenging deployment scenarios that operators have to face, and we want to understand how Open RAN technology performs and behaves in those types of environments. Obviously, it's a timing issue during that process to also be able to understand the date of and maturity of massive MIMO during that period of the Sonic program, and to see what capability massive MIMO has compared to what the operators are currently achieving today with their incumbent suppliers.
Great, thank you very much, Simon.
Dense urban it is then. Yes, let us move to the next speaker. It will be Michael Grote, Open vRAN Business Development Manager at VMware.
Michael is responsible for VMware's RAN business development activities in EMEA. Beginning with ESAT Digiphone in Ireland during the launch of GPRS, his career has spanned roles with OEM vendors, mobile network operators, and end-user organizations.
Michael will tell us about accelerating O-RAN ecosystem. Michael, the floor is yours.
Thank you, and good morning, everyone. If I had have known you were going to read out my bio, I think I would have put something a bit more interesting in there. So today I'm just going to talk about Open RAN, how VMware are helping to accelerate the ecosystem, and give you a bit of an overview of the VMware Telco Cloud platform. So let's see. Okay, so VMware, and when we look at VMware's involvement in telco, it began really back in 2016, where we started the virtualization of core network functions. So this has since expanded to offer a telco platform that's focused on making network virtualization simple and straightforward for service providers. But also VMware is about empowering ecosystem partners, and that's been at the core of our Telco Cloud platform from the beginning. And so we worked with Nokia and Ericsson, I guess, in the early days, also introduction of the OpenStack NFV edition, collaborations later on then with Samsung and Intel and others for 5G. So you can see it's always VMware working with ecosystem partners to deliver a solution that's right for the CSP or MNO. And what we see is that mobile network operators who adopt VMware's Telco Cloud platform, the main drivers in doing so are to accelerate time to revenue, to automate service life cycle, and really just to simplify operations. And from that, then we've seen the cost of core network functions decrease by significant factors. And we want to expand all of this kind of lessons learned, all of these advantages into the RAN space. And much of that is around leveraging O-RAN. So the offering from VMware, as you can see here on the slide, much of this aligns with the key benefits of Open RAN. So we talk about virtualized open architectures, and they promise lower OpEx, more automated and orchestrated networks, and includes enabling a vibrant ecosystem that's focused on collaboration, of working together. So if we look at maybe, Open RAN and how it has developed, maybe from a VMware viewpoint, there may be different viewpoints from other vendors. But if we look at it as a journey that really started with traditional closed RAN, so the RAN, and whether we're talking about radio, baseband, BTS, RNC, etc. They were all delivered by a single vendor, utilizing closed interfaces. And then, we would have standardized interfaces to the core network. So the kind of only multi-vendorness we had in operators was the radio provided by one vendor and the core provided by another. What that delivered was a monolithic network stack, like dominated by the three main vendors, much less competition, and a low and slow innovation cycle that was really, dependent on an OEM's roadmap, and was difficult for some smaller CSPs to really get innovation and get features and functions specific to their network. We then moved into more virtualized RAN. So I guess this taking some inspiration from the core virtualization and the successes we've seen there. So began to look at virtualizing the radio access network. In its most basic form, I guess this is moving the BBU simply from an appliance to a COT server. So the virtualization decouples software from hardware, allowing easier development and management, and providing a more agile RAN. But I think where we really focus on now, and what today is about, I guess, and a lot of the industry focus is on this Open RAN. So it leverages all of the benefits of virtualized RAN and adding open standard interfaces on top of it. So the front haul interface, I guess 72X was maybe the first real one that we've seen, an open interface being leveraged for live deployments and for this open ecosystem. But it's quickly moving to other open interfaces for management, for intelligent operations, SMO, automation, orchestration, etc. And Open RAN really allows smaller players to enter the market, which then brings more competition and delivers faster and greater innovation. And so I talked about radio, I talked about the 72X front hall interface, but I think it's important to remember that Open RAN, it's not just radio. Okay, RAN is radio access network, so we talk a lot about radio, but the promises of Open RAN, they extend far beyond just the CapEx savings of having a wider choice of RU vendors, of being able to take a baseband virtualized software from one vendor and mix it with a radio hardware from another vendor. You know, that's just an initial step, really. We talk about zero-touch provisioning, automation and orchestration, intelligent controllers to bring new efficiencies to the RAN. And that will help then in delivering both the CapEx and OpEx savings, as well as providing more agility and innovation. So VMware, we have developed an O-RAN compliant telco cloud platform. And this is to help enable the ecosystem to realize the full potential of a disaggregated and virtualized RAN. So if we look at things like workflow and decisioning engines to automate the traditional manual processes, automation capabilities to dynamically scale service resources to demand, you know, they're just some examples of where the VMware Telco Cloud Platform can help to deliver Open RAN as part of a wider ecosystem. And it is an ecosystem. So if we look at the RIC, for example, so VMware, we're building the platform aspects, the carrier grade aspects, the interface terminations that allow you to run low latency applications on top of a high performance platform. But we're also building APIs and SDKs that allow third parties to build XApps and RFs on top of this platform. So VMware is very much about building a platform for any cloud, any app, to enable CSPs to leverage O-RAN, but as well enable all of the O-RAN ecosystem to deploy on top. Let me see, I don't know. Sorry, I don't know if I clicked too far ahead. Yeah, there we go. Let's get the health side out. So VMware's vision is to provide the benefits of extending the cloud all the way from the RAN back to the core. So bringing the benefits of virtualization all the way out to the cell site. And for this, Telco Cloud Automation, or TCA, is our distributed cloud orchestration system. So it handles all of the development and lifecycle management of the network functions across all of the clouds in telco. So in telco, we don't just talk about core and cell site, there's edge, there's regional, and maybe even public cloud, AWS or Google. So two key areas of the telco cloud platform are being able to extend the logical clouds from regional sites all the way to cell sites, but as well the CI/CD pipeline with TCA. So Telco Cloud Automation is not just a day zero or day one orchestration system. It's an automation system for doing continuous integration, for testing and deployment of disaggregated network and vendor ecosystem. So one example of this in action, VMware have built a CI/CD pipeline in our lab where CSPs and the network function vendors can come and test their solutions on VMware's infrastructure. So that allows them to test their solution, define success criteria, define the upgrade process, and it's open to all network function vendors. So anyone who's developing maybe one of the vRAN vendors who's developing the 4G, 5G RAN software, any of the RIC app developers, you know, it's open to all. And it's a modern way of doing platform and system integration. So using modern cloud native tools to define the whole CI/CD pipeline. And I think this really allows smaller ecosystem vendors to test and ensure everything works and scales in an automated fashion before deploying it. So it removes the need to have to constantly build reference architectures for customers, to constantly build one-off lab and POC deployments, and bring it into something that's a lot more scalable, a lot more referenceable, and allows, as I said, any ecosystem vendor to come and test their network function on VMware's infrastructure. And so when we look at the actual ecosystem in general, VMware is enabling CSPs to have the options in both hardware platforms as well as the RAN vendors themselves. So the VMware cloud layer can be overlaid on top of the hardware platforms for RAN without having to worry about any cloud virtualization capabilities. So I think we've referenced some of the vendors we're working with here. So we're operationalizing Altiostar and Mavenir 5G stacks. They're fully containerized and fully integrated on top of VMware's cloud infrastructure on top of Intel's hardware at Dish. So this is a fully containerized deployment for both the DU and the CU. But we're also supporting other RAN vendors like IS Wireless, Radisys, Altran, ASOCs, and their CNFs on the VM platform. And that list continues to grow. So we have this ready for VMware certification process where anyone can come and certify their CNF as ready to be deployed on a VMware stack. NVIDIA have also announced their 5G reference platform. I think it's called Aerial, and VMware have already demoed NVIDIA Aerial on VMware Cloud back at the conference late last year. So we're working with not just Intel, NVIDIA, also Qualcomm to integrate the FSM platforms onto VMware's cloud, specifically or mainly focused on indoor and small cells and maybe private 5G deployments. So as you can see throughout this, we have a pre-testified and certified vRAN program to allow any ecosystem partner to bring their virtual or container functions into VMware Telco Cloud platform. And VMware's objective here really is to give the operators a choice on the hardware side, so that no matter which hardware vendor you choose, you can run VMware's cloud layer across that to virtualize and automate your infrastructure. And then also on top of the VMware layer, operators can choose which RAN vendor they want to work with running on top of VMware's virtualized platform. So it's this horizontal layer that runs on top of any hardware. And then on top of that, the CSPs can choose to run whichever RAN vendor they choose or whichever workloads they choose. And so it really does enable the O-RAN ecosystem by giving you this uniform layer across any cloud to deploy any of the workloads that we need for 5G and 4G, as long as they are then adherent to the O-RAN interfaces and open interfaces. So if we were to maybe start to look at wrapping up and say, what problem is TCP RAN looking to address? So we see that VMware, we're working with the Open RAN ecosystem partners to address basically the MNO and CSP, their pain points. So the initial phase, if you will, was to provide a disaggregated ecosystem with a free choice of virtual functions and vendors all running on top of generic hardware. And I think that has been largely delivered and proven now. I know we've done live trials and we have live networks running on it. But I think there's a lot more to do. That's really just the first step. So our focus now turns to delivering efficiencies. And it's not just energy efficiency, maybe as depicted here, but also spectral efficiency. We look at some of the demos that VMware have done with the likes of Cohere in DT. We're looking at using RIC apps to deliver spectral efficiency. But I think power efficiency is definitely top of mind as well for network operators. If they're going to deploy Open RAN, they want to see how they can also reduce energy costs and be more energy efficient. I think throughout this, we always try to keep agility and flexibility at the core. So we work a lot with MNOs in co-innovating, so enabling them to scale their operations to deliver on their customer needs. And I think that's really key to VMware, this idea of co-innovation and collaboration, not just with the CSPs and MNOs, but also with the ecosystem vendors. So then in summary, VMware and our O-RAN, why are we involved in O-RAN? TCP platform, it was originally core, we've now extended it to RAN. What do we see as being the main benefits? And I think one of the first is really a disaggregated and programmable RAM. So the modularity of this reduces the barrier to entry for smaller vendors, can provide smaller specialized functions instead of this giant monolithic stack that we were always beholden to. A multi-vendor ecosystem leads to increased competition. So telcos can choose between multiple vendors, select best-in-class network functions from different vendors. And more competition leads to more and faster innovation. Like Open RAN is expected to introduce new service capabilities like network slicing, 4G, 5G spectrum sharing, some of the RIC apps around spectral efficiency, and massive IoT. So all of this is enabled by having more competition, faster innovation. And then the virtualized RAN, so decoupling of software and hardware, enables the software-defined and cloudified RAN. So Cloud RAN leads to better utilization of compute and spectrum resources. So we talk about pooling gains, we talked about spectral efficiency gains through some of the RIC apps, and all of that, those gains are going to help towards lowering the CapEx and OpEx for operators. And software-defined RAN leads to easier and better orchestration and operations. So we have more agility. We have easier ways to orchestrate our networks. We have easier ways to roll out our networks with zero-touch provisioning, and then easier ways to operate, maintain, and do lifecycle management through all of the automation tools. So I think I've hopefully given you a good overview of VMware, of our TCP or Telco Cloud platform, and how it's helping to enable our ecosystem partners in Open RAN to deliver various network functions, various features for CSPs, as well as enabling the CSPs, the mobile network operators, to really realize the benefits of Open RAN, of being able to use any hardware with any network function from any vendor. I think that's the end of my slide deck.
Very much, Michael.
We don't seem to have any question this time from the audience, and we are up the clock. So we thank you very much for sharing your views on the ecosystem from the VMware's perspective, and we'll continue with the conference. Thank you.
Thank you, Michael.
Perfect. Thank you very much.
Let us move to our next speaker, Stephen Patrick, who is a CEO of Cable Free.
After studying at Cambridge University, Stephen gained wide-ranging experience in wireless technology and design consultancy. Having founded the company in 1996, Stephen has become well known as pioneer of high-capacity wireless communication technology with several world-first achievements within the industry.
Stephen will tell us about remote radio heads ready for Open RAN. Stephen, the floor is yours.
Thank you very much. It's a great pleasure to meet you all here and to introduce indeed our range of radios for 4G and 5G and our Open RAN project as well. So what we'll just dive into now on our slide deck is a brief overview of radios and how they fit in an Open RAN 4G and 5G environment. Just jumping into the slide deck. Talking about the radios themselves. So 4G and 5G, of course, the emphasis on 5G, but remember that people are still using 4G and we have to support both. And in the 5G NSA world, of course, the 4G radios use as the anchor and will be for a long time to come to make sure that a 5G network can connect with mobile handsets. So the radios we're talking about exist in both macro cell and small cell configurations. Remember, the macro cell is a large site, typically up on a tower or indeed a mast in the countryside. Small cells are used inside buildings to give localized coverage, shorter distances, and also outside on street corners, street furniture to provide additional capacity and indeed infill of black spots in coverage. So in our range, we're providing both the macro solution as well as the small cell. So they're distinct in both the product type and the indeed the application for them. One of the big challenges for 5G, as was for 4G, is the wide range of frequency bands that are being used around the world. So as a radio vendor, that's tough. You've got to supply all the bands that are needed. And as time goes on, more and more spectrum is being made available and therefore being used by operators globally. Therefore, we've designed a range of radios which provide full coverage of all those different frequency bands and are scalable and develop different power levels as well. So what does a macro cell look like? This slide here, which I hope you can see, shows a typical macro site, and it's got typically 3 or 6 sectors up on the mast. In the Open RAN world, of course, those have the lower PHY built into them. So those radio heads are typically mounted up near the cluster of antennas for low loss, and there's fiber optics and power coming down the mast. Now, of course, this could be a rooftop location. It doesn't have to be a tall mast in the countryside, but the principles are the same. In the Open RAN world, the distributed unit, or DU, is the blue box you see there, which are available from numerous vendors, is what connects to the Open RAN radios. And we might be operating quite high power levels. So at an RF perspective, 4G and 5G sites can run up to 20 watts or 40 watts per carrier, and sometimes even more. So for us, the radio vendor, the challenge is to build radios that will operate high power, reliably, conform with all the international standards, and do it in a robust and trouble-free manner, and do that across multiple frequency bands. So on the next slide, we see the converse. This is the small cell environment. A small cell is now typically a single radio, either up on a mast, or it could be street furniture, it could be a lamppost, it could be tucked inside a shop, a coffee house, or somewhere like this. Indeed, the indoor versions may be inside your office, your factory floor, inside a retail space. And these small cell base stations now typically are 1 or maybe 2 at the most radio front ends. The antenna is usually much simpler. It could be an omnidirectional or a simple directional patch antenna. And this is providing much shorter distance coverage, typically at lower power levels than the macro sites. Although we can build small cells with high power, the industry trend is to much lower power levels. And these are typically deployed in much higher densities. So inside a building or a factory floor, there might be 5, 10, 20 or more small cells. Compared to outdoors, you might see 1 macro site covering many kilometers. So as our previous speakers alluded to, the densification of 5G can be quite high with small cells. And they're providing additional capacity as well as infill coverage. Looking at actual radios themselves, people talk about MIMO. Now, MIMO is the most important technology in recent years to increase capacity. 2x2 MIMOs, of course, there's 2 chains through the air carrying data, and these radio heads you see here are the most popular, in fact, of the current shipping radios. 2x2 MIMO is widely used, particularly for rural sites and lower density. That's a great solution. In this case, we can support very high power levels. In fact, in this product, up to 80 watts per chain, which is great for long distance coverage. Most of the shipping products, in fact, are down at the 20 watts and below. We support all of the shipping bands, and remember that the defined bands for 4G and 5G span from 450 megahertz up to 6 gigahertz. This is a so-called sub-6 gigahertz range, and depending on the country and the operator or organization, in the case of private networks, you'll be allocated different frequencies, or different frequencies will be available. So the radio heads are available in those different versions, and we can build and ship those at different power levels as well. The connection to an Open RAN radio is typically IP Ethernet, and that's typically fiber optic, as the radio is up a tower and we need to provide isolation from any interference or other forms of disruption. But at short distance, it is possible to do that with a copper RJ45 connection. The slightly larger radios here is a 4x4 MIMO. In fact, the picture shows the maximally configured option. It's 4x4 MIMO with 40 watts per chain. So that's a considerably significant amount of RF emitted. Again, we have fiber optic connections directly to it. It's IP Ethernet in the Open RAN world, and that will connect to all of the third-party ecosystem that exists for Open RAN, both now and the future. I will pause to mention that we have reconfigurable hardware, so that inside the radio, we're using gate array technology and a lot of software-defined radio technology. So this radio can be reconfigured in the field and in use to adapt to conditions, to add new features, roadmap, and indeed new capacity as time goes on. So it's an extremely flexible item. And that's worth mentioning again, because most of Open RAN is focused on the software, which again is inherently easy to upgrade, running on servers. But when you get a radio, which is a physical manufactured hardware, it's up on a site, it may be difficult to access. Again, providing reconfigurability in the field, remote upgrades, gives the operator a much longer service life. The radio can be used for longer, much lower capex, because you don't need to visit the radio to do things. You can do these updates remotely. And of course, therefore, the overall value of the network is far higher. It's worth noticing the heatsink fins on these. So the higher the power level, the larger the fins. Everything's passively cooled. There are no fans involved in outdoor radios, and typical to most radio vendors, the heat sinkings need to take away the power. There's a big focus at the moment on energy efficiency in 4G and 5G. A lot of operators have put their hands up and said, our energy bill is costing us so many millions a year in the case of big operators. And now, of course, in the modern era, we're concerned about the green eco-credentials. If we're going to connect all the users on the planet, can we do it in an environmentally responsible manner? So the radio design teams are always focusing on energy efficiency as a significant and increasingly significant topic these days. Moving on to spectrum and frequency levels, this chart here simply shows the available bands and power levels which can be achieved with today's technology. And this is always moving, this chart, the capability of both RF front ends, the processing, and everything that goes around it to make a state-of-the-art radio head. So we can see that at the low frequencies, much higher power levels are available than at high frequencies. This is actually due to the actual semiconductors used in the front-end amplifiers. But it's also matched by the use case. Most operators are using low frequencies for long distances, rural coverage, and using the high frequencies inside cities for urban coverage. So there is no one size fits all with frequencies and coverage. You need both. You need the rural coverage with low frequencies, and high frequencies, you need the urban coverage. And therefore, the density of cell sites is higher. Also, remembering that high frequencies don't penetrate brickwork, concrete, and structures at all well. And therefore, again, an overlay of both frequencies are needed. So if we look at 3.5 gigahertz, for example, which is widely used for 5G networks today around Europe and many other countries, the density of those 3.5 gigahertz radio heads needs to be significantly higher than it would be if we were looking at lower frequency for rural coverage. And this, again, is this densification topic that's mentioned earlier on the conference. And in fact, on the very high frequency bands, we can also be limited by regulation, that regulators around the world will be limiting the power levels to ensure that there's no interference between users, especially in the new class of shared spectrum or spectrum sharing bands. Ofcom in the UK took a lead in Europe of enabling 3 bands, which means that almost any organization can go and apply for a frequency license for their specific area. And the power level is very low, but it does mean you can now build a private 4G or 5G network, buy radios from vendors like us, and light that up today. So yeah, those power levels can be linked to both the laws of physics, the operating environment you're in, the technology that exists today, and of course the regulatory framework, the power levels which you're allowed to use. Next one, of course, is indoor small cells. So we mentioned these. The use cases are quite diverse. They do include wall mount, ceiling mount, factory floor, desktop mount, but particularly for the industrial automation side, we believe that's a very strong case for indoor small cells, where people want not necessarily even people, but machines to be operating and connected in real time. One of the advantages pointed out by customers is 4G and 5G technology allows seamless roaming, whereas in the past, often they've been using Wi-Fi, which does not. We also make Wi-Fi equipment, and there are challenges in trying to make Wi-Fi roam at high speed with robots and machines in factory environments. And these users have reported back to us that 4G and 5G technology is much superior. You can apply quality of service and roaming mobility much better in an automation environment. So we do make the indoor version of small levels. Power levels are lower. Remember, these radios will be close to people, and there are strict rules about RF emissions. And of course, both the installers and behind that, of course, as the equipment manufacturers need to build equipment which is designed for use in spaces. So typically it's under 1 watt, 250 milliwatts is quite a common specification for indoor use, which by the way is a lot lower than a high power access point for Wi-Fi and a lot lower than the transmit power amps in some of the cell phones. So it's a very responsible and public friendly solution. So looking at what could be the benefits of a radio for Open RAN, of course, is making sure we have radio heads that are available for multiple bands. The traditional model from vendors is they only support the major bands. So if you want the ones that the big operators use, you can buy the radio heads. If you get given a piece of spectrum that's not so popular, too bad there's no radio heads. So we've designed a solution which is much better. It does allow you to use any band that's available, and especially for small operators, government, public safety networks, private networks, that's a huge advantage. You can get whatever sliver of spectrum you're allocated, and we can provide radios to operate in that band. On the modulation front, today's radios are running at 256 QAM, and the standard allows for 1024 QAM, which again is supported. So that puts enormous demands on the RF processing, all the way through the subsystem, linearity, distortion, compensation, and other technologies that are used to deliver crystal clear signals to your user device, whether it's a mobile handset or an industrial CPE, or for fixed wireless access, maybe a box on your house delivering broadband into your premises. The MIMO chains 2x2, 4x4, and we can deliver 8x8 if needed today. Earlier on the call, people mentioned massive MIMO. In fact, that is a different category of product. We as a vendor aren't building them yet. They're only used by tier 1 operators and only in ultra dense spaces, which again, our colleague Ofcom earlier alluded to, is that the tough one is how to cover maximal spaces. So of course, there's a roadmap for doing that, but today's products span from 2x2 up to 4x4, and this option for 8x8 MIMO. And of course, the IP interfaces span from 1 to 10 gigabits per second. Open RAN does put quite a high data rate for those RF samples from the core all the way through the DU to the radio head. RF coverage is a big topic. So people talk about how far will it go? Laws of physics, we mentioned earlier, there are planning tools for designing this, for ensuring you have the best coverage, looking at different frequency bands, but the equipment is designed to provide the very best in class coverage, whether you're rural, urban, indoor in a factory unit, or office space. And we can provide a range of planning tools and deployment tools, which will give you very detailed or a quick cursory glance before you deploy a network. And indeed, coverage and range. People say, how far can 4G and 5G go? It depends. It's always the answer with radio signals. It depends on what spectrum you've got available, what your capacity targets are, clutter, and other factors which can affect RF propagation. And we have planning tools which will give a very good view of the available coverage for the 4G and 5G network. Lastly, here's where's the future? People always say, what's going next? Of course, people are always looking for faster capacity, higher speeds, and better coverage. So there are answers to all of those. One is for multi-band radios. This is where we're providing a radio unit with 2 bands inside the same hardware. So that's one box goes up on your wall or mast, and it's providing basically a low frequency and a high frequency signal from the same box. And in today's networks, that also gives a big advantage of being able to run 5G NSA in a single box. Remember, NSA means you have a 4G bearer as well as the 5G bearer for the main data channel. Millimetric 5G, for sure it's coming, already deployed extensively in the US, now coming to some parts of Europe and the rest of the world. And higher frequency radios bring with them many more challenges, particularly on the data rates, which are much higher. And of course, the deployment is where do you put them and what happens with coverage, which can be quite short distances as well. And lastly, people are always talking about beamforming and active antenna arrays, where we can steer the signals to specific users. That works in some scenarios and not in others. So again, it's a question of what's relevant for the deployment case, and very much what problem are we trying to crack in the deployment by the operator or user. So that's the end of my presentation. You're very welcome to ask questions, and we're happy to debate and ask questions all the time on 5G and 4G networks. Thank you very much.
Thank you very much, Steven. Great presentation. Do we have any questions from the public?
We do have questions, actually 3 of them. And you, Steven, mentioned a lot about characteristics of your O-RAN radio heads. There is a specific question of the benefits of this equipment compared with the ones from traditional suppliers. And then there is question on the, can you name few MNOs that uses cable-free equipment and where is the equipment manufactured?
Those are excellent questions, as always, so thank you very much for those. So we'll go in reverse order. Manufacture in the UK, designed and manufactured in the UK. And that's unusual. People raise their eyebrows and say, how did you manage to do this? Everyone else is shunting off their manufacture to maybe lower cost regions on the planet for economic reasons or where centers of excellence are. We've picked very much the biggest talent we have here in the UK. We assemble the radios here in Oxford, on the Oxford Science Park, and we're proud to make sure they're available, not just in the UK, but globally. We have exports of these radios. One of the other questions are which MNOs are using them. Well, so that is confidential, but we have, as a strategy, started with tier 2 private ISPs, fixed wireless access, and there will be some public announcements in the coming weeks about new networks which are deploying these radios. And sure enough, as a strategy, we have the tier 1 operators for later, but typically, as always happens, is tier 2s move quicker, and ISPs and government networks, and tier 1s have to plan many years ahead. Their networks are huge, so that may take a little longer to implement in their networks. Sorry, can you remind me the third question, please?
Sure. So the question was about the benefits of this equipment compared with the ones from traditional suppliers.
Absolutely right. So there are significant benefits. And one of the reasons for this is technology is moving very quickly, both in 4G, 5G, and the underlying RF and signal processing technologies. So by using the very latest in software-defined radio, reconfigurable radio hardware, RF chipsets, it means our radios are using the very latest available. And with the design we've done, it means if there are future updates, it's a modular design. We can make sure that in 1 year's time, 2 years' time and beyond, we can be using the very latest across all the frequency bands. Whereas a traditional radio design from a major vendor is stuck in time. They'll design, say, a 600 megahertz or an 800 megahertz radio. It'll stay in production 5 years. And when they come back to 3.5 gigahertz, everything's different. And so their refresh time is longer. So that's a major benefit for these radios, is because it's a modular design, we're able to update that and provide the very best technology. And that translates into, of course, capacity, distance, penetration coverage, and of course, roadmap supporting the latest features that are needed in 5G and beyond.
Thank you, Steven, for all those exhaustive replies.
Thank you very much.
You're most welcome. Thank you.
Let us move to our next speaker, Gerasimos Klaudatos, I hope I'm pronouncing correctly, from the 5G go-to-market incubation team at Hewlett-Packard Enterprise.
Gerasimos is responsible for growing HPE's 5G market share through new offers. Currently, he's focused on incubation, pipeline generation, and sales of 5G Open RAN solutions.
Gerasimos will tell us about Open RAN ready servers. Gerasimos, over to you.
One announcement, we will hear Gerasimos and we will see his presentation, but we will not see him due to some connectivity issues. So let's wait for 5G to improve this, but now the floor is yours.
Hey guys, can you hear me well?
Yes, we can hear you well.
Okay, sorry about my camera. I've been having problems for the last 3 weeks and I cannot solve them. Okay, so thank you so much for having me over, guys. Hello, everybody out there. Hope you're healthy, safe in this weird world we live. So, yes, so I hope from the event so far, it has actually become clear now that 5G actually enables the creation of newer and faster services, right? Along, of course, with the user bandwidth increase that comes as a result of moving to higher frequencies, like, and we heard about, the so-called mid-band frequencies. Now, of course, and that's the theme of the conference, for the potential, this potential of 5G to be fully unlocked, 5G needs to become, and is actually becoming more cloud native, more open, more disaggregated at the run sites, at the run level. And this is what this presentation is going to about. So what actually HPE is doing from a compute perspective. So if you see now this slide here, right? So at HPE in general, virtualization, disaggregation for 3G, 4G has always happened at the core, right? If you remember, we used to have this monolithic appliance type of solutions there where all the APIs were proprietary. And as a result, we needed to have different multi-vendor heterogeneous platforms for each application or group of applications. So what happened is the hardware was disaggregated from the software of the packet core, and then we ended up having virtualized packet core components, the so-called VNFs. Now, the same principles are now spreading to the RAN, and this is all we are talking about. The radio software, traditionally sold by network equipment providers, running on their compute and based on their proprietary interfaces, now is being basically disaggregated. What do we mean by that? The RAN software components, namely the VDUs, the VCUs, are virtualized. They are becoming cloud native. They are running in containers, and all of that will run on an x86 type of compute at the RAN side. Now, this is the first thing that is important, right? Yes, we've done disaggregation. We've done it in the past. We are doing it again. The difference here is scale, though, right? Because a typical operator would have probably 75,000 RAN sites out there. The sites can be small. The sites can be in very dense cities. There may be power, space, sometimes, I don't know, harsh environmental conditions. So extending the disaggregation, yes, but also the form factor in terms of density, in terms of carrier grade, in terms of all these things has to be considered into the RAN sites. And this is what we are focusing here, right? That is aggregation of the compute at RAN sites. Talking to operators around the world, what are the benefits of that, really? There's three benefits, right? The first one, primarily, the first one is that it actually does reduce the cost, right, for the new radio introduction, which, as we all know, is very expensive. How does this reduced? By enabling best of breed procurement. So tick here, right? Great. The second one, which we've been talking about in this conference, is also it enables new use case introduction. So we all know that mobile subscription in terms of money is not going to increase, right, that much. So how are we going to capitalize on these massive 5G investments we are making out there? One way to do that is to add applications at the edge. You know, the types of MEC, the types of network slicing, the types of private cellular networks, all of that stuff now can be brought easier to the edge. And this is the whole idea. But if we are going to do this, then traditional RAN infrastructure, the traditional compute that it's already there, doesn't serve that purpose greatly because it only supports radio software, right? Here we're talking about more applications. Therefore, we need multi-purpose, high compute stuff on the RAN side in order to be able to do that. So that's the second thing. And the third thing, which I'm sure you've heard from other speakers before me, is that by doing that, this disaggregation, this we do with ORAN, innovation and evolution is also fastened, right? Because at this point in time, then, with disaggregation and cloud native concept, a new feature comes up, from a radio software. All you have to do is, to containerize it and basically drop it on the compute platform. So all these upgrades now are becoming much, much faster. So now let's go a little bit. What is the strategy that we see becoming the main one when it comes to getting this disaggregation on the RAN sides, right? So you see in the slide right here at the what actually has also become apparent by talking to operators out there is that when you do these things, guys, you do not go with a product approach. They wanted vendors to look the full solution, not here is a server, and that's it. No, they want us to create a solution, and support the ecosystem. And this is what we are doing here, right? So at the bottom here, you can see the compute infrastructure, right? We will talk about it a little bit more. That's ORAN optimized general purpose hardware infrastructure for the edge, right? So that is the DL basically 110 if you're talking about HPE's proposition. The other thing that is very important to notice, and you can see the thought leadership enabled through ORAN, is that that whole idea of edge fabric, right? The whole idea is how we remove infrastructure elements, such as the cell site router, such as the front hall gateway, and actually put them as cards into these compute PCI slots. So the whole idea here is how do we reduce all these boxes at the edge, 3 at this point in time, to basically 1, right? And then, that will bring, of course, cost down and complexity down. So this is the bottom, right? As you're moving upwards, of course, then we take this platform and we need to add software on it, right? We need to add operating system and we need to add, a software, cloud software like, Kubernetes. And in a standard telco sense, at HPE, we test these configurations. We create pre-integrated performance-optimized reference blueprints. And that's how we actually de-risk deployments for our operators out there. We have done that with chip manufacturers. We started with Intel. They have a program, for example, called VRC. We've tested everything, if you want to get technical, all the UEFI settings, the firmware profiles, the performance targets. We've done that with the cloud providers, the likes of Winter Rivers, for example. Then we have tested, the host configurations, the cloud configurations, the performance, and things like that. And we are ever expanding with more vendors of those things on our compute. Then if you are moving a little bit higher, then you can see that on that box, on top of all this, you have to accommodate the software, the radio software, right, from the vRAN software vendors. And it's paramount here to actually have them testing their software on the compute platform. So we get involved with almost everybody out there, and they are testing the cloud network functions on this platform. If we move a little bit more upwards, then you have edge management, right? This is very complicated and very, very important. You need to manage these things at that scale. You need to make sure that your hardware works, and by hardware, I means, it includes the BIOS, it includes the firmware, it includes the various cards that are there, the NICs, the FPGAs. So it's a much more than just a compute platform to manage. So you need a single pane of glass. You need a GUI front end with automation capabilities in order to do things like activation, upgrades, commission, decommission. And we do work with a lot of vendors inside HPE, outside HPE, in order to come forward with one solution. Then, of course, on top of that, you can start adding all kinds of services from the very vanilla one, warranty, tier 1 care, foundation care, all the way to customized services. The other thing that is also important is the how do we reduce the overall staging and deployment time for our operators. This is a disaggregated world. It's becoming much more complex. Therefore, we need to have some sort of pre-stage kind of capability services in order to help them. So from an HPE point of view, this is our strategy. We work with vendors out there to create all this stack in order to come to our operators. Now, if you want to talk a little bit more about what is that compute platform we are talking about, so it is what you see here is the DL110, we call it, or within HPE, but it's an optimized platform for RAN sites. Now, what do we mean by an optimized platform, right? There's 3 things, right, that optimization means at the RAN side. The first one, it is form factor, right? This is an 1U, shallow depth, front cabling, front mounting server, and fits the customer's RAN sites. And why am I saying this? It's because, remember, these sites are out there. They have already been built. They are already at this point in time populated, right? So operators out there, they are not going to change them just because, we are disaggregating. Therefore, you have to fit that environment. So form factor in a disaggregated world in the RAN side is very, very, very important. The second important thing is all about density, right? Remember, 5G is about narrowband frequencies, which exist today, but also it opens up mid-band frequencies, right, in order to support higher bandwidths. What does this actually mean? It means that you need more radio units, right, than possible today. What does this mean then if you need more radio units? That means we need to connect those radio units to the compute platform through Ethernet, right? So what do you need then? You need enough PCI slots on your compute to support this. So in our case, we have already made this with 4 PCI slots, right, to accommodate all these NIC cards which support this network connectivity. And also, of course, you need to add accelerator cards according to the needs of the environment. And also on the RAN side, jitter, latency, very important. So we have to make those slots basically capable of that. So in our case, these are all PCI 4.0 slots, right? And from a CPU perspective, it's all about latency. How do we reduce latency? And that's why basically the first iteration of that is a single socket CPU. The third optimization consideration for the RAN is carrier grade. And this, as we all know, is an absolute must for operators out there. The box needs to be fully compliant when it comes to thermals, seismic, from a seismic standpoint, with all the proper certifications, name it, NEBS level 3, GR 3108, whatever. It has to be carrier grade. So anything that goes on the RAN, these are the 3 qualities that we need to make sure that we are accommodating. So that is from the compute perspective, right? Now, the other thing I wanted to show you, I always like that slide, that actually shows, again, the capability that O-RAN unleashes, if you like, right? And what you see here is how we can even reduce cost and complexity at all these thousands and thousands of RAN sites out there. If you go on the left side, it's the appliance model we all know right now. We need primarily 3 boxes. You need a front haul gateway, which consolidates all the traffic from the radio units. You need a compute platform for the processing of the radio software. You need some sort of a router which connects you back to the near edge sites or your packet core network, right? All of that today is by one vendor. Now, what we are envisioning and we are doing is basically reducing all those to just one box. How do we do that, right? Is because the compute has a lot of slots out there. So you can actually theoretically and practically get rid of that frontal gateway and replace it with a NIC card from Intel. There's many out there, Westport channels, STS2 from Silicon, Kronos Creek, whatever that is. So here is one box gone. The other one is the router, right? You can actually replace the router with a NIC card. This can be a smart NIC card. Broadcom is good on those, and then you can use a virtual router to add the routing capabilities. So here is another box gone. So all in all, if you now start comparing the cost of this structure with the appliance structure, with the disaggregated version, you are saving about 30% in acquisition costs. And don't forget, right, it's not only that, it's the reduction in indirect costs that you're now saving, because you're having 66% less boxes to manage, to upgrade. You have lower overall power consumptions. From an operator standpoint, they have fewer vendors to manage. So you can see why this is becoming very appealing. this whole idea of disaggregation at the core, at the edge. The other thing now that it's important to mention is what you see here, right? Disaggregation of hardware and software at the edge adds a lot of complexity, therefore requires some intermediate steps towards pre-integration in order to de-risk that environment for the operators. So as a vendor, HPE provides blueprints. Used to do that and still does that for the core. We are doing that for the edge. So basically, we are working for the chip manufacturers. We are going to Intel and we'll say, let's test together our reference, our vRAN profile. What is the reference BOM? What is the UEFI settings, the firmware profiles, the vRAN performance targets? We do that, right? Then we go further. We are going and work with the cache vendors. Let's verify the Open RAN host configuration, the Open RAN cache configuration. Let's verify the cache performance and functionality. And all of that then creates, if you like, an edge cloud reference, if you like, which we give to the operators, and then they can assure that they are already in very safe hands by us doing that. And also, apart from that, we also publish, performance benchmarks, right? Working with partners out there, things like the throughput, the latency, the bandwidth, the number of cell carriers, the power consumptions, all of that stuff is included. And this is basically our view of how we de-risk RAN deployment for the customers out there. Now, another important thing is what happens with basically two things, right? How do we help operators deploy at scale? Very important, because there are many thousands of RAN sites out there in a disaggregated manner. And the second is how basically we help the operators manage and operate all those sites at scale. So there are two considerations we are working on. The first one is all about basically staging and deploying at scale, right? So we provide the capability and the services to reduce that overall staging and deployment time. So take it from day -1, right? Before a compute goes to the site, to the RAN site, you can offer a combination of actions executed on that hardware platform before it gets to the RAN site, as we said. Basically, we can preload systems with all the common components and settings, which, do you know what? It saves about 3 to 4 hours on day 0. Per server. So if you go now on day 0, then vendors like us do not play in this space. This is other companies there that they actually go to the RAN sites and they make the node ready for launching it on the air. But remember, you have already saved 3 hours. So all it takes, it's about 10 minutes. And then you have, of course, a day +1 combination, which is what can be executed post-deployment. The second area that is very important is this whole idea of management and automation at scale. This is a must, right? The scale of edge deployment is huge. We need automation. And there's 3 primarily areas around this. Is at the front end, how do you visualize things? How do you view the far edge or the near edge, the equipment there? How can you drill down to the required edge? All needs to be GUI-driven, single pane of glass. The second thing is, what do you do on the back end? How do you automate operations? How do you manage hardware and software through their APIs? This needs to be automated. And of course, the third part to it is there must be a capability in order to basically to customize, if you like, the environment of management and support per customer, per operator individual needs, development of user interfaces, development of workflows. And as I said, we work with lots of companies inside and outside our own, basically in order to come up with that capability to our customers and to our operators. And this is the last slide here. So this is just, we know all this, all that stuff, but basically just stressing that a very important success factor in this whole idea of ORAN is promoted through alliances and consortiums. We all know ORAN alliances. We all know the telecommunication infrastructure project from Facebook. So, and my company works and it's part of this organization. And the way this works is that the ORAN Alliance provides specifications to the various groups or groups which parts of the telecommunication infrastructure project, and then they take the hardware, they take the software, and they create all these reference designers, de-risking again, and speeding it up. And in these alliances and in these forums, there are customers, there are system integrators, there are NEPs, they are all there. So it is important for vendors like ourselves to put our platform there, participate in their work groups in order for this whole idea of ORAN to get deployed faster and safely for our operators. And with that, I am done, guys. So thank you for listening and your attention.
Gerasimos, thank you very much. Thank you for the great presentation. And I believe we have some questions from the public.
Yes, we do have a question from the audience regarding clocking of the CPUs. There is a comment that the HP DL110 supports currently 4 Xeon CPUs, where the most powerful CPU has clock at 2.3 gigahertz. Is that enough for virtual DU applications? Some DU apps claims they need CPU close to 3 gigahertz. Gerasimos, any comment on that?
Yes and no. I'm not the most technical person on earth to answer this question, but yes, I think it's enough. But within HP, we are always coming with new products and new, CPU's capabilities, and the whole idea about openness. Remember, right? You can change this, right? And an open platform, you can have a CPU from Intel, you can have a CPU from AMD, you can have a CPU from wherever. That's the whole idea. If you need more, you can get more, right? It's easy. And yes, we can support it, yes. A different CPU, if you like.
Thank you very much.
Awesome. Thank you very much. Thank you for the presentation. And let's move to the next part.
Thank you very much, guys. Thank you. Take care.
Bye-bye.
Thank you. Bye. With that, we are moving to our next speaker, Anand Upili, who is a co-founder, CEO, and executive board member of Tambora Systems.
Anand has 33 years of experience in telecom products and services industry. He's a serial entrepreneur. Formerly, he co-founded VistaPoint. Earlier, he was regional sales director at Telabs.
Anand will tell us about building next generation edge. Anand, the floor is yours.
Thank you very much. I hope you are able to hear me.
Yes, we can hear you loud and clear.
Yes.
Okay, and good day, everybody. I'll get into my presentation right away. So the idea is to talk about the ecosystem and how the new edge can be built. And the new edge is built at the existing cell sites. It is run on a nano data center, and it has all the components. It has the radio component or the RAN component. It has the core from Tambora or somebody else, and then it also has the internet component, whether it is compute or whether it is the content. And the layer cake would look like this, and we've again, this connects back to the ecosystem. At the base level of the stack, we have the hardware, which could be Intel based or ARM based, and then we have the operating system. It could be something like Linux, or we are working with our partner EdgeX. They have their own operating system. Then we have the virtual machine or the containers created by the hypervisor or the containerization platform. And then we have the various software workloads, whether it is the RAN from IS Wireless, the core from Tambora, the compute from, say, Salesforce, or the content that could be a Netflix video. And then we have the hyper orchestrator and the hyper automator. We at Tambora, we work with Robin.io. Again, there had been discussions about the importance of automation and also what benefits the orchestration would bring in and how it would optimize the cost of the hardware. Moving on, looking at the different kind of deployment scenario and how the new edge we are talking about is different. In a traditional edge deployment, there could be a hyperscale data center which is located outside the mobile network. The closest it could be, it could sit right next to the mobile operator's private cloud data center. And then the traffic ripples through the entire mobile network. A second option could be that there is a micro data center which is located outside the mobile network. There are new edge companies which want to set up such kind of micro data centers in a container. And this has, I would say, the so-called tromboning of the traffic. The traffic has to happen or loop back. It ripples through the mobile network, it goes through the internet and comes to the data center, and which could be a micro data center. The third scenario could be the data center being located within the mobile network. Then there has to be additional intelligence to route or offload the traffic straight away from the RAN into the data center. So the data center in that case incorporates, let us say, another mobile core, a simpler mobile core. Then where we could come in, or the new edge where it could be deployed is, it's a nano data center. It is integrated with the existing RAN and it is deployed at the existing cell site. We kind of summarize everything as a table and we look at all these 4 different scenarios. We see that the edge could be located outside the mobile network or inside the mobile network. If it is located inside the mobile network, the delay is less because it is not, the traffic is not rippling through the entire mobile network. And then in the new edge, the scale of the data center is the smallest. It is like 4 servers at the foot of the cell site, need not be at every cell site. So it is like a nano data center. And the infrastructure is, in the case of the new edge, it utilizes the existing cell site. It uses the enclosure available at the existing cell site. It is using the power backup, and all the other infrastructure elements that are available at the existing cell site. In all other cases, the infrastructure for the data center has to be created from scratch. And talked earlier about the delay components. In the case of something which is inside the mobile network, that the delay components or the component that induce the delay in the traffic are less because there is only the RAN and the core. Again, the core is needed to divert the traffic. In the case of the Tambora approach, the RAN is highly optimized. The core is talking to the RAN. Earlier, people were talking about the schedulers, the scheduler control, and all of that. So we could reduce the delay that way. And also, our core, the Tambora core, is optimized for the edge applications. And it is optimized to deliver the minimum possible delay. And talking about how our core is different, one is it is a light core which is optimized for the edge. A traditional approach, if the edge data center is located within the mobile network, as I mentioned earlier, in the case of a 4G, it could be a full P gateway or S gateway. In this conference, we are focused on 5G, and the 5G has a distributed architecture, so it would be the UPF, but then it could be the unoptimized UPF, because then to select the traffic and all, you need the feedback loop or the control element coming from the control plane elements of the 5G, or through an application function, or as the 3GPP has envisaged, through a CSMF that talks to a NSMF for network slicing, and then everything rippling through the UPF. So all this calls for a lot of software, and the costs are higher because there are more software modules running at the edge. Our approach is to provide only the essential components optimized for the edge. And these essential components are closely coupled with the radio. And in the case of 5G, to start with 5G, they are optimized, and the UPF has all the control elements already integrated for plug and play. So at the edge, the traffic can be intelligently diverted or intelligently offloaded either to the MEC platform, or let us say to the big black internet cloud there itself. And this control can be at a very granular level. It is at a session level. Every it's like micro granularity. And then it can be controlled by a number of factors. It could be based on subscriber parameters like their MSISDN or any of their identities. It could be based on the application, what kind of application they're using. And then it could be offloaded based upon the network loading conditions. It could be based on the device, whether it's Android or Apple, or what kind of device it is. So the light core provides the full functionality. The lightness is on the number of software modules. There is no compromise on the feature functionality. And it provides a higher economy because only the minimum essential number of modules are run at the edge, saving on the hardware resources. The other uniqueness is to drive the disaggregation to the next level. Earlier again, Arthur, in his introduction to IS Wireless, had talked about the disaggregation of the radio stack in the different layers which are available as APIs for external devices. So we take full advantage of disaggregation that is provided by our partner, IS Wireless. And our code is also completely disaggregated. Our code is completely disaggregated. The end result is we are interleaving the radio and the core. Traditionally, for the radio, there will be a single pipe. It would be the GTP tunnel in both the cases. In case of both 4G and 5G, that is fed into the core. Now we have more touch points, we have more APIs, and we have what I would say more feedback loops. Our core is application aware. When I say application aware, it is aware of all the traffic, it is aware of the network congestion or the network loading. All that intelligence is processed by the core, and the core interacts with the RAM in a very meaningful way. And that interaction is at a microservice level, and that interaction is across the stack. So we could interact at the MAC level, looking at the scheduler. We could interact at different levels of the stack. We could optimize some of the GTP parameters, cut on the delay. So a number of use cases are now possible. And with such an integration, the RAN cost could be optimized. We talked about different model, the densification model with hypersaturation, the MIMO model, and then the RAN being the most significant part of the mobile network CapEx, and Rakuten and all have done already the first level, the Open RAN, which gives 30–40% cost savings. Now this would take the savings to the next level. The RAN now is super optimized, and a cell-less architecture can be very simply implemented. And now the entire network design has become a fractal. Instead of a hierarchy of a RAN, core, OSS, BSS, it is like a fractal of a network. Everything being available as, let us say, one logical box. Just a moment, I'm trying to cycle through my slides. I have some problem in cycling through the slides. Yeah. The other key differentiation we have is the kind of sensory inputs we build. We build a very rich mosaic of information from all the bits we gather, not just from the mobile network, but from across the ecosystem. We get some inputs from the mobile phone, and we get inputs from the content server or the MEC platform or from the internet. And this information spans multiple dimensions, including subscriber details like MSISD and IMSI. Then what kind of application, what is the QoS that is available for the application, what kind of network loading, how the network is functioning, and what type of devices are using the network. Then the new edge could be built by different categories of players, and we support all the different models. A mobile operator could build the edge for reaping the benefits of the vRAN and the ORAN, like what Rakuten has done. So they create edge data centers, and those edge data centers are running the radio stack with a section 7.2 split or whatever. From there, they graduate to having a mobile core at the edge, offloading the traffic, saving on the backhaul bandwidth, and then they could build up new revenue streams by collaborating with the Googles, the Netflix of the world, and could offer a host of edge services. So that is one set of business model. And in this case, the edge is built by the mobile operator. There could be another set of business model where the edge is built by the tower core, and it is all centered around the neutral host. There was also earlier discussion about the neutral host, and we take full advantage of a disaggregated RAN and a disaggregated core to slice the network, share the infrastructure, and then a tower core like a Cellnex or an American Tower could move up the value chain. They are not just offering power and tower, they are offering network as a service. And in the network as a service, there could be different levels. They could offer the edge data center infrastructure as a service. They could offer radio as a service. They could offer the entire mobile network, the radio and the core as a service. They could also get additional revenues from the content and the application providers, from the Netflix, from the Salesforce of the world. The third business model which we support is a specialist edge core. For example, we're working with EdgeX, a specialist edge core. They are building the edge. They have their own operating system. They have their own hardware. They put up the edge nodes, and then we coexist with those edge nodes. We enable such an edge core, a specialist edge core, to be a neutral host like a tower core and have multiple tenants. They could also offer their, what I would say, their core business model, where they become a highly distributed CDN for the content providers, or they could offer edge compute. And they could also provide private 4G or private 5G networks in a campus or in a high-rise business building, and then everything can be sliced. Each tenant has their own slice of the network, highly secure, and they can set the QoS parameters, what they want. And then it could also be used to support the fixed wireless operators. To get into some of the details without overloading the audience in a morass of details, the result or of what we do with the new age and our very advanced core is we look at maximizing the cell throughput, increasing the RAN saving. Now the core is interacting with the radio. It's not like a simple S1 interface or a simple N interface in the case of 5G. So there is a more efficient allocation of the resource block. And in a highly densified network, there is a feedback loop to make sure that the modulations, the user is in a higher modulation scheme because it's a super dense network. We cannot move the user, but we can switch on the cell which is serving the user so that he is in 64 QAM or 128 QAM or 256 QAM in a higher modulation scheme, and then the schedulers are controlled. There could be even multiple schedulers. The lighter packets, for example, chat packets could be on one scheduler. The video packets, which are bigger packets, could be on another scheduler. And then in the case of a hypersaturated network where there are layers of radio, that could be a 700 megahertz, which is providing the coverage, and under that umbrella, there could be the 3.5 gigahertz, and then there could be millimeter waves providing spot coverages, and then there could be dynamic traffic movement between all these cells. All of this is enabled by the core, and the core, as I mentioned earlier, our core is highly intelligent. The other one is the savings due to the core being more efficient. We are increasing the data plane throughput. We use all kinds of acceleration tools, SRIOV, BPF, and we use it whether it is an Intel processor or an ARM processor. And then there is all our patented technology so that the application of the policy it doesn't bring down the network performance. And earlier there were some questions from the audience about performance on a different context. And here we achieve wire speed performance. And then the way our software is structured, our microservice architecture, we do a lot of our processing, almost all of our activities at the kernel level. So the control packet or the workload is not rippling across the kernel to the application space and coming back. So all of this increases the throughput, what we could get out of a virtual CPU, which is created by the hypervisor or the container platform. Then there is also the underlying hardware optimization. The disaggregated software itself, again, people were mentioning about that earlier. It provides the interleaving capacity so that the hardware is completely utilized. Then there is the efficiency of the software, which I talked about. Then there is the hyper orchestration that is provided by our partner like Robin.io. And then we could look at the different families of processors, whether it is Intel or ARM based. So the net result of all of this is a very flexible, fractal kind of a network, which has the RAN and the core, and which could be deployed at the edge over existing facility, rather than create a new facility. Slawomir was also talking about optimizing the infrastructure. So this optimizes the infrastructure to the core, reduces the cost with the disaggregation and the hyper automation. It provides a lot of capabilities, a lot of flexibility to create new services. Thank you, and back to Rafael and Alexa.
Anand, thank you very much for this insightful presentation. I believe we have a question, right?
Yes, thank you for this new view on the edge. We have a question regarding the OSI model. Interleaving of radio and core at stack level means the traditional OSI model no longer applies. This is a question, whether the lower layers are offering services for upper layers. How does the OSI model play with your solution?
Okay, so here, I'll get into a little bit of detail. First, we don't want to disturb the existing model. And also, all the 3GPP interfaces, whether it is in 5G or in 4G, they remain as it is. What we are talking about is not disrupting the data plane traffic at all, even though there could be some data plane optimization. It is achieved on the control plane. It is achieved through the open APIs, for example, IS Wireless provides. And through those APIs, we are able to communicate to the scheduler. We are able to look at the frame. For example, we could have a punctured frame under certain conditions. We reduce the load on the RAN because the RAN, the radio doesn't have to analyze the packets. The intelligence is coming from the code, and we have our AI engine, we have our machine learning, and then we are able to trigger. So that way, in summary, we are not disrupting any of the existing protocols or existing interfaces.
Anand, actually one more question. Thank you for that explanation. If you would like to comment, what is the minimum hardware specification for the edge in order to run the system?
Again, it is a completely virtualized environment. So what we would say is that rather than talking about a minimum hardware configuration, we will talk about a vCPU. So, or a virtual machine. Typically, our virtual machine would deliver about easily 4 or 5 gigabits, and which can go up to 10 gig. So each virtual machine can handle typically a number of radios. And then it is completely elastic. We keep on adding as many virtual machines as needed.
Thank you very much.
Thank you very much, Anand.
Thanks.
Without further ado, let us move to the next speaker, Zygmunt Łoziński, Senior Technical Staff Member, Master Inventor, and Quantum Ambassador at IBM.
You know Zygmunt already from the debate at the beginning of the conference, but let me introduce him once again. Zygmunt is responsible for technical strategy for telco network cloud in IBM's global telecom and media industry, across Edge, 5G, NFV, and SDN. He has been working on the use of cloud technologies in the network for over 10 years. He led an early implementation of edge computing with a major operator, which ultimately led to the creation of EdCMEC.
Zygmunt has advised operators in over 40 countries on technical strategy and architecture. And today, Zygmunt will tell us about Telco Cloud, the importance of a horizontal platform. Zygmunt, over to you.
Thank you very much. Okay, tries to click slide. Well, that's happening.
It works. We can see your screen.
Oh, okay. I can't. That's okay. So you heard earlier from Michael McGrorty about the importance of a horizontal platform, and he focused very much on the importance of a horizontal platform in the context of the RAN. I'm going to look at a horizontal platform more broadly, not just at the RAN, but also at the edge and at the core, because all of those are important for operators today. And really, we've reached a stage in the industry where we're at a crossroads, and I think the thing that's important is cloud technology, virtualization technology are now a key element of how we build networks. Once upon a time, networks were vertically integrated using proprietary hardware, proprietary microprocessors even. Now the cloud provides the technology that everyone uses. And we're also seeing two other developments. The importance of the edge is going to become important for operators who are deploying both Open RAN and virtualized core networks. And we're also going to see artificial intelligence and machine learning play an increasing role. One obvious example in the context of Open RAN is how artificial intelligence algorithms will enable us to have a multi-vendor open self-organized network using the RAN intelligence controller, the Open RIC. Again, that's, I think, something that will be important. And I mentioned the importance of edge. Operators see that their consumer services will not generate the revenues that are required to justify investment. And therefore, a lot of operators that I'm working with want to deploy edge platforms in addition to a cloud-based core network, in addition to looking at how to virtualize or cloudify the RAN. And the point I think is important is that we should have a common cloud infrastructure that supports all of those use cases, supports the network core, it supports the RAN, and it supports the edge. And that reduces the operational costs by having common processes and common technology. And the key element that's important in this transition is that we have to take the cloud model, both in terms of cloud technology and the cloud operating model, and to bring that to the network. And I'll talk in a little bit about the potential benefits, the economic benefits that can bring for operators. So, we start off with a network where both the core and the radio are deployed using custom physical appliances, physical network functions. And over the last 7 or 8 years, as NFV has become more widely adopted, a number of vendors have moved to providing their network functions as software modules on commercial off-the-shelf hardware using one of the various virtualization or open cloud platforms. But in many operators today, each of the individual network elements is implemented as a separate logical appliance, if you like, a separate virtual appliance. And what that means is that there's no real difference from an operational point of view from the old physical world. There's no commonality in the operating processes for the infrastructure, in the operational processes for the actual network functions. And that is the next opportunity we have to move to a common horizontal infrastructure upon which multiple vendors network functions either delivered as VNFs or in the future as containerized network functions run. And if we do that, there is a substantial economic benefit to be gained. And that's, I think, one of the critical things about a common platform. Now, in order to address that, we've looked at, IBM has looked at what's actually required. And at its heart, you need two things. The underlying platform itself. So you have to start with like the operating software layer, whether it be OpenStack or whether it be a Kubernetes platform like OpenShift. You'll see both of those continuing to be important for the coming future. So that's one element at an abstract level. But then the other thing that's absolutely essential is a focus on automation. Because if we're going to deploy, even within the packet core, if we're deploying a packet core for a country, we're talking about, let's look at India, 200 instances of the packet core within a single operator. If you were deploying those from the command line, that's going to take far too long. And so what we do instead is we wish to develop a set of automations. You can call that orchestration, which allows us to define and deploy, according to a catalog, all of the elements that make up a network function running on a cloud platform. And that's the single biggest objective here. Now, if we think about what this looks like in practice, we expect that within the network itself, there will be a cloud platform that runs all the VNFs and the containerized network functions. And so one of the things IBM has developed is a program. Obviously, we have OpenStack and OpenShift, but we've added to that Cloud Satellite, which allows those nodes to be themselves automatically deployed and centrally managed. And that Cloud Satellite platform can run in the 10, 20, 100 core network data centers, depending on the operator scale. But they can also run at the edge locations and ultimately can support the radio access network itself. And if we're going to use a common cloud to support the RAN, that potentially gives us an opportunity to also support the mobile edge, the MEC, which will start off, of course, being deployed at MSC type sites, but over time we will see MEC sites move to the edge. So we have that common infrastructure layer which supports multiple vendors. And then on top of that, almost certainly centrally deployed is the network automation suite that provides both orchestration for the deployment of VNFs and CNFs, and also closed loop assurance, so that whenever events happen, that is handled centrally. And you can see that model over time will also be used by, for example, the RAN intelligent controller, the idea of a closed loop taking events, which is common today in assurance and will continue. Now, there's some flexibility for an operator in that we will see operators who want to deploy network functions on a private instance of the cloud, where the cloud is physically, the network cloud is located on the operator's own premise. But there are already today operators running core network functions like an Evolved Packet Core on the IBM public cloud. And in case you think that's a bit strange, we talked about during the debate the UK Telecommunications Security Bill. And one of the questions I asked the UK government when that was being proposed was, you have a set of security requirements. How do you think about public clouds? And the answer was interesting. And they said, we expect that the major cloud providers like Azure, IBM, AWS will put a lot of investment into securing the cloud infrastructure. And therefore, we believe that that is certainly an option for operators to choose to use. It's up to the operator how they deploy their network. But if they want to put network functions on a public cloud, there's no reason from a security point of view why that should not be done. And so I think that's an interesting observation. And so when we look at that public cloud, the operator may put its management functions there, they may even put network functions there. Now, if we go on, let's look at the business value that you can expect from such a platform. We think that having a common operating model for this cloud infrastructure should apply both to the telco network and potentially to other workloads, to edge workloads and to IT workloads within the context of a telecoms operator. And part of the reason for that is it means that you can consolidate all of your different vendors onto a common platform, which in turn reduced costs. And that makes it easier for the teams within the operations who are managing the deployment of the network. It reduces the complexity of the job they have to do. And certainly this is what we found when we did this for one of our major clients, that this significantly reduced the time to deploy those packet core sites which are running, of which they have perhaps hundreds, which run both packet core and potentially IMS functions. So that simplification is important. And at the same time, if we try and quantify this, if we look, for example, at some of the benefits, obviously common hardware means that the capex is reduced. Since we have a dynamic platform, we don't necessarily need to build to the peak of all services, but we can also simplify operationally. And in our experience, when we've done this for clients, the cost of moving from multiple siloed virtualized platforms to a single common platform with a common operating model is actually enough to pay for the transition costs. And so it's actually cheaper after you've done that than it was beforehand, even after you've paid the cost of the actual transition. And I think that's quite significant. So our recommendation is that we believe everyone should be taking this approach, but not just in the context of the core network, but in the context of the edge network and the radio access network as well. All of them will benefit from this approach. Now, in terms of the underlying technology that's required to do that, fundamentally, zero-touch automation is possibly the most important on top of that underlying platform, as I mentioned. The other thing I'll make a point about is the importance of enabling us to have automation and machine learning, because that is where we get the ability to, for example, in the future, that's where the Open RAN RIC will fit into the network. It will use the artificial intelligence model management in order to deal with both the near real-time and the real-time RIC using common AI models. Okay, so behind all of this, IBM and Red Hat together have built a stack that has all of the software elements that are needed in order to provide this, starting at the bottom with OpenStack and OpenShift. So you have both virtual machines and containers. Cloud Satellite then gives you a deployable unit that can fit into any of your network locations. On top of that, network automation and orchestration are essential. One thing, if you're looking at edge applications and you're looking at selling those to enterprise customers, one of the things that we'd highlight is the importance of managing the life cycle of both edge applications and machine learning models, which we believe will be an important element of services like machine vision to drive a robot in a factory. That's a function that, as an operator, if you're trying to deliver a MEC, that edge application management is an important service to consider. And finally, this would only work if there's a broad ecosystem of partners, and we've been working with our partners to try and ensure that network functions of all types are certified on this underlying platform. Marketing slide. So some examples of operators who've actually talked about what they're doing. I mean, a couple of people who are using OpenShift as their containerized platform. But Vishant Vora, who was the CTO and on the board of Vodafone Idea in India, now VI, he's talked about how they used this approach to build the what he calls microclouds, which are these 200 locations which run the packet core. Obviously, India is a large country with 400 million subscribers. You need lots of packet core, but a catalog that enables you to automatically deploy the particular VNFs that you've chosen. Catalog says you can do Ericsson, Huawei, Nokia, Samsung. Which one is going into any particular one of those microclouds? What are the hardware requirements? How is it mapped into the NUMA models of the servers you've got? All of that stuff is captured in the automation so that you don't have to go and repeat the task of designing each one separately. And again, the importance of edge management for both telco workloads and for the enterprise workloads that many operators today are saying that they want to offer. I'm working with one client in North America who's trying to work out how to deploy edge applications in the automotive industry, because that's important to them. The other element we believe is really important is to avoid lock-in. You want a common infrastructure, and then you can choose which network functions to run on top of it. That's your choice. And one observation that certainly companies like IBM and VMware equally are not going to be using your data for their own business purposes. We'll provide you with technology. And one of the risks, one of the questions you always have to ask when you look at some of the hyperscale clouds is for companies whose business model is in using potentially certainly subscribers' data, then there's an interesting tension there that I think you have to think about. I mentioned the importance of the ecosystem. We heard that at the very start of today, and I was really pleased to hear that. We certainly believe that as well. And one of the critical things is we've been working with our partners on how to get their network functions running on our cloud platform, how to get them running with our automation. And we are going to continue to do that because that's essential to building this open ecosystem. And if anyone, we've heard a number of people today who've got interesting network functions. Come and talk to me afterwards. We're always interested in new partners. So with that, I'll just summarize by saying the steps that you need to be taking is to start with the underlying platform, to move to automation and orchestration, and those are the two, to me, critical steps of the journey. And then once you have those in place, you can look at how to make use of the edge. and what you might do there. With that, I'm going to say thank you very much. Thank you for your time. I hope you enjoy the rest of the day.
Presentation, very informative. We don't have time for questions, unfortunately, so we have to move forward. Thank you very much again.
Thank you.
Without further ado, let us move to the next speaker, Łukasz Mendyk, Senior Solution Manager at Comarch.
Łukasz specializes in solutions based on the concept of intent-driven fulfillment and orchestration, as well as on innovative concepts such as software-defined networking, network function virtualization, and end-to-end orchestration of 5G networks with O-RAN and based on distributed cloud.
Łukasz will tell us about digitalizing industry, 5G network orchestration with O-RAN and edge computing for industry verticals. Łukasz, the floor is yours.
Okay, thank you. Welcome, my name is Łukasz Mendyk, and today I'm having a presentation about digitalizing industry, and in particular, what is the role of communication service providers in doing that process. From technical perspective, I will also describe the concept of intent-driven orchestration of distributed cloud with O-RAN and edge, and all this in respect to various requirements coming from different industry verticals. So let me start with agenda. First, I will provide short introduction. Later on, I will try to summarize, describe challenges which communication service providers will probably face. Then I will quickly outline the answers in the form of bullets, because last point of my presentation would be a proof of concept, which is to define how this answer can really work, so enterprise customers can be approached by telco operators. So I think that in this forum, I don't need to introduce what 5G is, but I think it's worth mentioning that I think it's common understanding that 5G is meant for enterprises more than consumers. And you can take it even from this picture, which is currently presented, that technically 5G defines three main types of communications. So it's not only about massive mobile subscribers, but also from massive machine type communication, and especially ultra reliable low latency type of communications, which is targeted for automation in manufacturing. And that's another slide which depicts that 5G is really all about the tackling enterprises, is the concept of network slicing. We might say that network slicing is to enable operators to provide to different verticals, which can expect different behavior of a network, dedicated as if dedicated networks, and all implemented on ideally shared infrastructure. So in other words, that telco operators should be able to provide dedicated solution to verticals without, in fact, investing in dedicated hardware and physical infrastructure, and have the network slices dynamically created. But of course, we don't need to take from the specifications what the expectations of operator are, because we can take it from the operator service. And this is the slide which presents the light reading operator survey, which was about 5G network and service strategies. And I took just two diagrams to present, because which are significant to my presentation. First one is about the time frame. Majority of operators answered that addressing 5G edge services is within 3 coming years. So I still believe the time is now, because if you are deploying the solutions, you need to work quite early on business use cases. So that's why the time is now. The second chart is even important, I think, because it also describes ambitions on telecommunications operators in respect to the role which they are to play. And as you can see, 31% of telco operators say that we, telco operators, will lead the engagement with enterprise customers. 26% believe that they would work with partners, but still they will be treated as equal partners. In other words, we might say that majority of operators have quite huge expectation that they will play a really important role in digitalization of the industry. And of course, money behind that means that revenue share which telco operator will get will be equivalent to their role. So the question is if these expectations are really founded, and what are the challenges to this concept. I have taken also the report recently published in April by RCR Wireless, and the first opinion comes from industry itself. The enterprises quite openly say that we don't give a damn, which sounds very scary, I think, for telco operators, but probably it means that approaching enterprises can't be just saying we are bringing you 5G and 5G label should open all the doors to that industry. Rather, it means that telco needs to do a great job to convince that 5G is really transformative technology for the industry. Second opinion is coming from automation specialists, and I think it's even more harsh, meaning that this type of specialists say that they are to play the dominant role in providing the 5G to the industry. So they are positioning themselves as the main player here, and they even decide that they should develop the ecosystem by themselves. In other words, it might mean that telco operators can be treated here as if energy provider, where energy is something which does not bring much value. The third opinion comes from the internet news, which is an opinion expressed by facts, I would say. We already see that private 5G networks are treated as isolated islands, and in such cases, telcos are not needed, and equipment vendors can claim and compete with telco for such businesses, saying that the only thing you need is to get sorry, something with clicking is to get from network vendors what you need for automation in the industry, and that is true even for LTE. So for 5G, it can be also true. Next opinion is coming from Vodafone, which is a representative of telco operators, and they still perceive the value of running the network, believing that it's that once the network is there, showing their competences if managing the network in a real-time regime is the key competence, leveraging the network operation centers and offering the services in the form of a managed service. So as we can see, communication service providers, especially public telco providers, expectations that they will play the dominant role is not that obvious. And they are going to face a lot of challenges in that field. So for sure, 5G industry is not going to buy 5G just for the sake of 5G. They need to be convinced that that technology is really transformative, and telco needs to fight for the role in the ecosystem as a real enabler for automation and digitalization, speaking more broadly on the industry and economy. So what are the answers? I will briefly go through these answers, and then I will try to present some use cases. So what is the answer? One of the answers would be what I call intent-driven automation. It means that here by intent is probably overused buzzword, but here intent means that verticals industry is not going to buy directly network slicing. They probably would like to avoid defining technical requirements for the network because that's not their business. But for sure, they would be interested in defining the automation use cases and buying the products in the form of industry-focused applications, which then will drive the network automation. In particular network instantiation and designing the proper network for the vertical. The second answer is slicing for private 5G. I'm smiling a little bit because it's a little bit tricky case, because if we approach private 5G network as isolated networks, someone might say that that use case defies the need for network slicing, because you can build the dedicated network for that purpose, and you don't need the additional abstraction layer like network slicing. But I think that even for big companies like car manufacturing companies, which have a budget probably for having dedicated solutions, they still might need to run distributed factory. By this I mean that they probably own more than one factory, which are distributed geographically, and for sure they want to see they factory as a one single organism. So for sure you cannot treat private 5G as an isolated island. The second sector, I think, which might be even more interesting for telco operators, is small business. Why? Because for small business does not have big budgets, and here 5G could be really the transformative technology, which is to bring the automation. We might say that in car manufacturing factory, the automation is already there, but for small business, 5G could lower the barrier of having more sophisticated automation within the business. Moreover, small businesses might work in the scenario where they hire the space in a bigger factory, and they share the space and infrastructure, physical infrastructure, with other businesses. So the network slicing is a perfect match for such a use case. Third option is about the tools, about that operators probably should appear as a provider of a platforms which also enables innovation in automation of the industry, meaning that that they should position themselves as enablers for application developers to quickly introduce new applications based on artificial intelligence, and applications treated as a cloud-native application. Of course, for that, underneath that platform, telcos will leverage the 5G standalone network with network slicing, Open RAN, and edge computing. And of course, it's not about that telcos should do everything, but rather to have partners onboarded into their platforms with vertical application developers on top, and vertical automation specialists also included. And of course, cloud providers like Amazon, Google or Microsoft with its Azure service. Of course, other partners are Open RAN vendors, for example. So how these answers can work on real business use case. So I prepared some concept of simple, but I think also some use case which can be quite informative and good for learning by doing the process of telco tackling the industrial automation. So the use case assumes smart factory, which smart factory of course is a buzzword, but here smart factory means tackling the systems, real-time system. I mean here that the assembly line could be equipped with video camera and as a sensor, and a robot arm with as an actuator, and some artificial intelligence-based applications which can recognize based on the image if the product is faulty or passes the quality of control. And this simple use case can demonstrate the need for ultra-reliable, low-latency communications, and 5G here is important for tackling the use case. And moreover, even if this use case looks naive, we can say that in a single factory, you can have many assembly lines or assembly lines with multiple stages. So even such small concept of closed-loop control automation system composed of application and sensor and actuators can be used to build quite complex solution. To give a bigger picture, we can say that factories are not isolated islands. So I'm proving previous statements. And this use case can be nicely combined with already existing concept of smart factory, where smart factory was limited mostly for getting some data from the factories and aggregating them in the cloud, and then providing some analytics for running the business. Of course, this application didn't require real-time communications, didn't needed 5G. So let me focus on smart factory itself. as I said previously, that use case might look naive, but in fact, I think it might be interesting from several aspects. One of them is that, as I mentioned, automation specialists object to the role of telco because they claim that they already control systems based on so-called programmable application controllers, which are dedicated hardware. So this use case first tries to leverage the concept of applying artificial intelligence, machine learning to enhance already existing automation inside the factory. So it's not about fighting and replacing the existing systems, but rather tackling the use cases where artificial intelligence based applications for sure need cloud computing, and cloud computing which is at the edge, so that you can guarantee low latency communication. So from vertical perspective or automation developer perspective, network is transparent. And I think this is the perfect ally to Open RAN and network slicing. In this case, even Open RAN is deployed in the scenario where only radio units are physical in the form of active antenna, as the rest is hosted on the local, in the factory edge cloud with virtualized network functions. And also I'm presenting here UPF as a part of next generation core element, which can be moved closer to the edge, or in this particular case to the edge, and provide all of this in favor of reducing latency. I was mentioning that the key to the success is intent-driven orchestration. So I would like to elaborate a little bit more on that, because that's probably the key aspect. As I mentioned, the telcos can't expect that industry will buy and order network slices per se. Rather would like to have a platform where they could concentrate on the things which they understand and they need. In this example, the product could be just a single closed loop automation control system composed of sensors and actuators and intelligent application which needs to be run on the cloud. And from applications provider for this automation, in this case, don't care for network, because they treat that it exists and it works. So they can define the only vertical related parameters. Other aspects could be intent-driven automation means that intent is automatically translated to the what network you need to build or to instantiate, what network slice you need to instantiate to fulfill the requirements coming from the vertical. In this case, the simple form would be just to translating the profiles of the sensors and actuators to 5 QIs, which could be understood as common language between the vertical and industry vertical and the network specialist. And going further, knowing how much IoT devices with known 5 QIs, how many control loop systems you have, you can calculate the burden of a network in the way that you can still support the low latency requirements for the applications designed by the vertical specialists. Of course, we can go even further, but the KPIs coming from the verticals can be translated to purely network-related KPIs. I quoted some examples of them, like, for example, GNODB DEU delay between GNODB distributing unit and the IoT device, and going further to latency introduced by the slice. Other part of KPIs could be the KPIs related to the infrastructure itself, especially in the cloud infrastructure like CPU usage and RAM. Some of those requirements may come directly from the application developer saying how much RAM it needs to host the application. Others are related to hosting the VNFs of Open RAN and UPF function. Of course, this picture is simplified. It's not showing the control plane, just the user plane. So to sum up, the whole concept assumes that the magic should come based on product, service, and resource catalog, which should enable to do the translation between intents expressed by the language of the vertical. Language means product specifications of control loops, automation control loops, subsystems, and translation them to services which needs the network slices to provide. And finally, identification, how to instantiate the network, how much resources need to be allocated. Moreover, this concept also assumes that once you deliver, you also monitor that, and you can learn what happens if you would like, if a vertical wants to add a new assembly line, whether we need to upgrade the physical infrastructure, or the physical infrastructure is capable of delivering its services. Okay, so that finalizes my presentation. So thank you.
Thank you very much for your presentation. Very interesting technical dive. So thank you very much. And we will be back in a minute. Please stay with us.
Welcome back. We would like to introduce our next speaker, John Schimpf, who is a senior director of the product marketing at Marvell Technology.
John is responsible for product management, product marketing, and customer and partner relationships for Marvell's portfolio of LTE and 5G RAN solutions. John joined Marvell by way of acquisition of Cavium. Prior to joining Cavium, John held a similar position at Wavesat, a developer of 4G wireless baseband processors for mobile devices.
John will tell us about the role of the chipsets in open ecosystem. John, the floor is yours.
Very good, thank you. As I said, John Schimpf from Marvell, and appreciate you guys having me this morning, or this afternoon for you, to talk about a slightly different concept here. I think the idea of first, my focus will be largely on Open RAN, and in addition to that, I think one of the things we haven't heard too much today is the perspective from a silicon supplier. And so this, I hope, will add a little bit more dimension to the overall perspective of how 5G is coming together, and in particular, what's happening as Open RAN becomes more and more a desire and a part of what I think we will be seeing more of as 5G rollouts continue. So let me take just a couple of minutes and introduce Marvell for those of you who don't know us that well. The one thing I will say is that Marvell is, our business is very much about connectivity. We have a range of products, and I'll give a quick overview of those in just a second. But by our estimate, over the past 15 plus years, we've shipped in excess of 100 million pieces of silicon to the industry to support networks. And this is silicon that ranges from network processors to baseband chips to PHYs, just a whole range of products. And as I said, our focus is very much on infrastructure. So network infrastructure, data center infrastructure, that's what Marvell does. So I won't spend a lot of time on the details of the silicon that we supply, but you can see that in the RAN, we have a very complete portfolio of silicon from the radio unit. And this is silicon that is either merchant or custom or semi-custom. So we are a leading supplier of semi-custom solutions to many of the tier one OEMs. We also do merchant silicon, and we are a leading merchant silicon supplier for the data center and for network infrastructure suppliers from the RU into the base station, the DU, and into the central unit as well. I think we jumped ahead just a little bit. So as I mentioned, what I really want to focus on today is talking about how we are viewing the silicon requirements for Open RAN. As I mentioned, supplying 5G technology and silicon technology into the market, we are the leading merchant silicon supplier. So we are well steeped in what is required from the semiconductor standpoint for the traditional networks, whether 3G, 4G, or now 5G. But Open RAN introduces a different set of considerations. I think that what probably most of you have seen is a desire on the part of many operators to consider an Open RAN approach in addition to, or perhaps ultimately to replace, a more traditional style RAN. The desire is based on having more cost efficiencies, looking for the types of innovations that a larger supplier community can bring. One of the consistent requirements from the operator standpoint is to figure out ways to reduce the overall cost of the network. And so Open RAN really has promise to be able to do all of those things. But at the same time, there are things that are important considerations, things that are not necessarily a given without a lot of consideration on the part of multiple suppliers, whether that's software or hardware suppliers. These considerations include the performance of these networks, the Open RAN networks. I think one of the things that is very apparent is that if a RAN is going to be open, it still has to have the same performance capacity as a traditional network, so it's not going to be acceptable for the RAN to be something almost as good or in the same neighborhood, but actually must meet the same stringent requirements on performance, on reliability, and ideally the goal is to have a lower cost RAN system. But in practice, I don't think that's quite occurred yet. So I think that there is more distance to cover in order to get to the point where these Open RAN implementations are also as cost effective or more cost effective than a traditional RAN. And we've heard a lot today about the idea of virtualized RAN. And for Open RAN, I think there is an idea of, is it a vRAN? Is it a disaggregated RAN? And it seems pretty clear to Marvell, at least, that the answer is yes. So the types of Open RAN deployments that we will be seeing, it's going to depend on the particular operator preference, but I believe that there will be both disaggregated RAN approaches and virtualized RAN approaches as well. I think that in order for these approaches to be successful, however, that the same considerations need to be covered certainly from a system and silicon standpoint, and of course from a software standpoint. So as we've embarked on supporting a number of Open RAN trials, and as we've observed some of the initial Open RAN deployments, and there are a few, I think Rakuten is sort of the poster child for Open RAN deployments. What we're seeing is that while quite a number of operators and a lot of vendors, including many that we've heard from today, have embraced the concept of Open RAN, there are still a number of things that need to occur in order for Open RAN to really make it into the mainstream. And the types of things that I'm talking about are hardware platform choices. One of the important things is for Open RAN not to turn into just a new set of suppliers that mimic what the traditional network suppliers have done. So the hardware platforms need to continue to encompass different suppliers. This includes all of the elements on the DU, the CU, on the radio units. And so you can see here that, indicating some of the participants that are, potential suppliers or are actually suppliers on the hardware side. In the case of Marvell, we fall into the ARM camp. I think the software availability is a particularly important area, and our hosts from IS Wireless are included in the vendors that are supplying technology, software technology. But I think there's still a place for additional software that is proven for Open RAN, and this includes both the protocol stacks for LTE as well as 5G. And I think LTE is still important as well, that we don't overlook the fact that many networks are still LTE based and will continue to be for some time. So I think it's important that there is the ability for these Open RAN deployments to be dual mode for the moment. Eventually, there will be a more complete transition to 5G, but LTE is still in the game. And as well for the network cores and for the RIC. So there are a lot of participants that are looking at Open RAN as a way to expand their footprint in the market, and I think that's really great. At the same time, I think it is important for this software to be tested, to make sure that the reliability is there. One of the things that we have seen in the Europe case in particular over the past few months and as recently as the past several weeks is that the expectation from the group of 5 operators that have proposed some requirements for Open RAN in terms of their specs, but also in terms of the requirements for performance and for reliability. So the hardware and the software needs to absolutely meet those specifications for Open RAN to be viable in Europe and around the world. One of the other areas that I think that there are some strong needs in the industry is for system integrators. And I think that in general, the complexities of deploying a RAN are well, it's very complex and it takes a certain expertise. And I think what we're seeing is that the number of integrators is relatively small compared to the number of deployments that are going to occur globally. So one of the areas that we're looking for more participation is in the integration side. Okay, so with all that, how does Marvell fit into this picture? And as I mentioned in the beginning of the presentation, what we do very successfully is provide silicon for network infrastructure. And so what we have decided to do in the past year is to take the same approach to Open RAN, which is basically to take the type of semiconductors that we provide to OEMs, tier 1s, tier 2s, worldwide OEMs, and make versions of that silicon available to the Open RAN community. And it's not just silicon. I think in particular for Open RAN, it's important to have a more complete offering, because once you remove a fully integrated tier 1 supplier, then it will fall to the OEMs and integrators who are providing Open RAN services to have access to reference designs. So I'll talk in a minute what we're doing in that aspect, on the software development kits, and also protocol stack software. So making it easier for the suppliers, the Open RAN suppliers, to bring these technologies into to the operators. And one of the things that we've heard a lot today, and I think, I don't know if I've listened to a presentation that didn't emphasize ecosystem partners, so I'll do that here as well, because I think, again, what will make Open RAN successful is a robust and active ecosystem of software suppliers, integrators, and new OEMs. So on the reference design side, what we are doing is providing essentially an RU that is a high capacity 32T, 32R RU design in conjunction with analog devices. So this is fully integrated. This is an RU that an OEM can pretty much take and put into the field. It includes hardware and importantly the software. So the design is for a 7.2 split. The software that's supplied is the lower L1, the beamforming software, the RFIC control software, and the DFE software. So the idea here is to be offering something that is very complete, ready to manufacture, ready to roll into a deployment. On the DU side, we have two variations that speak to both the disaggregated approach as well as to the virtualized approach. They incorporate our network technology processors for both running the CU and the DU software, so the protocol stack software, as well as the Octeon Fusion processor, which is our baseband chip. So we're providing an integrated reference design that includes, all of the usual things, schematics, all the design files, but importantly, the LTE and 5G reference software. So this is, I think, really critical for the OEMs to have a solid foundation, a starting point for the reference L1, and being able to take that and readily modify it for a particular deployment scenario. We're also partnering with the third-party protocol stack, the L2 and L3 software vendors, including Radisys in this case, who have ported their protocol stack onto the Octeon processor and have a fully integrated. And I think it's important also just to mention the importance of having that software well integrated. So the more that we can do as essentially the ecosystem suppliers to the OEMs, the faster they can bring these products into the market and get them into deployment with the operators. And we're doing the same thing with the virtual offload accelerator. So it's a different form factor, also incorporating the same silicon, the Octeon Fusion baseband processor, in this case on a PCIe form factor. It runs complete L1, so it's an inline L1 accelerator for a 4G or 5G offload card. There we go. Sorry. Okay, and then one of the things, and this will be the last thing I really talk about today, is looking for ways in Open RAN to help expedite this process. There have been, again, I had mentioned Rakuten previously, and I think many of you are probably familiar with the amount of effort it took for Rakuten to bring together a whole range of suppliers to manage to pull off a network deployment in Japan. And it's not the case that there's going to be such a luxury, I think, for most operators to be able to sort of marshal that many forces together. And it's certainly not going to be cost effective to have that kind of a model where it really requires, a small army of suppliers and integrators to make the network possible, an Open RAN network possible. So one of the things that we've been looking to become active in are some of the efforts that are being spearheaded by some of the groups that are trying to make this more of an streamlined process, if you will. And one of the places that we are investing our effort is the Facebook Connectivity Evenstar program. And this is a program where they are bringing together and really helping to, in some cases, fund some of the effort, to involve some of the network operators in field and lab trials, and to really try to almost harden some of these solutions to make it possible to understand how to pull all of the RAN pieces together to make it possible for different market participants to be able to really make the promise of Open RAN real. So what we're doing in this situation is that in Facebook Connectivity, they have spec'd out an Evenstar radio unit design and a CU. And in our case, we are providing the DU. So this is a DU that looks similar to the reference design that I showed on the previous slide. And in this activity, we'll be supplying also the layer 1 protocol stack software. Another third party will be providing the L2, L3, and pulling together a ready to deploy RAN solution that can then go into network operator trials. So there will be several that are being lined up as we speak, and the first will begin by the end of this year. And then this program is intended to expand to additional participants on both the software side and on the hardware side, and bringing in different integrators to really have a chance to see how to make this all work, and to work again within this concept of an overall ecosystem that has access to the right kind of equipment and the well-integrated software and protocol stacks. So I think this is one of the things that we think is key to making Open RAN transition from very specialized use cases into a more broadly deployable and really future-oriented approach to network deployments worldwide. So one slide too fast. Anyway, some key takeaways. First is that there is growing interest in Open RAN solutions. I don't think that's probably a big surprise to anybody who's attending today. I think Open RAN has got a lot of momentum. I think one of the things it does is it brings more participants into the market, which we think is good from an innovation standpoint, as well as from an opportunity to help manage network deployment costs. The network operators are keen to be involved with Open RAN deployments. But at the same time, the only way that it's going to work is if these Open RAN deployments meet the stringent requirements of price and performance that are expected, and reliability that are expected in the type of deployments they do today. There are still some gaps in the Open RAN vision, and these are gaps that we are trying to help fill from a silicon vendor standpoint. But it's also important that other members of the ecosystem are also actively contributing to and participating in the trials in order to ensure that Open RAN is going to be successful in a commercial sense. And I think the number and some of the industry groups, the O-RAN Alliance, the TIP programs, the Small Cell Forum, and certainly the Evenstar program that we are involved with are all key elements to ensuring that Open RAN is going to be a successful RAN approach in the next several years. So that's what I have to say for today. Thank you very much.
Thank you very much, John, for showing your perspective from a chipset vendor, and also your insights on how the ecosystems are evolving and how they could be evolving even more optimally. Thank you for being with us today.
Thank you very much.
Last but certainly not least, we are looking forward to hearing Wojtek Burkot, who is a co-founder and CPO at Bait Incorporated.
Wojtek is also partner at Bitspiration Booster VC, and in fact, that's how we know each other. As mentioned, he's co-founder and CPO of Byte Inc., developing quantum algorithm designed to solve NP-complete problems. He is advisor and board member for several startups, including Exotech, Asimo, Early, and others. Previously, he was CTO at Grupa Allegro Marketplace Division. He moved there from Google R&D Center in Krakow, which he set and ran. Prior to Google, Wojtek worked in a number of roles at Motorola.
Today, Wojtek will tell us about telecommunications of the future from the VC perspective. Wojtek, over to you. We can see you, we cannot hear you. Maybe you're muted.
Possible?
Yes.
Yeah, how about now?
It works.
Welcome back.
All right, so I don't see myself, but it is okay, I see the clicker. Good afternoon, good morning, whatever the time is in your time zone. I'm Wojtek Burkot, and actually I've been talking about Open RAN from the perspective of a VC. I'm a partner of the Diversification Booster VC, but being a partner of the VC is not a real job, so I'll draw heavily on my past at Motorola and at Google for that perspective. Obviously, as the paradigm shift from the big vendors of the equipment to more open environment and many more competitors in that market is interesting from the point of view of the VC, only if we can find the true pearls or diamonds in this field. So let me talk about how we see this and why. And by the way, we are also an investor in ISN, the organizer of today's conference, and some of the companies they spawn for the specific purposes. So the VC investments, some people claim, I should see that. Yeah, sorry, too fast. So some people claim that their investment, being a VC partner, is strictly data-based. I'll try to convince you that it cannot be the case. And then yet there are some rules and some signals which you can use as a VC investor to hope for the outcome, for positive outcome for your investors. So you might have heard those buzzwords coming from the VC world, like 80% of profits comes from 20% of the portfolio, and that we need 10x returns on the investment to cover our losses in other investments. Also, the rule of thumb, just 1 in 10 startups is going to succeed. This is all not based on the reality, and I'll try to convince you that that's the case. So the first question you need to ask is whether the very notion of the average and the average number of startups which fail, average return, has any meaning in the VC world. And regretfully, or maybe luckily, it doesn't. VC do not live in the normal world. The behavior of our data is not normal, so you couldn't really draw conclusions about the averages and invest based on that. The VC investment is governed by the power law, and the closer you are to the point where you don't have the average, so the alpha of 2, the better chance for the significant returns you get. And from that graph to the left, to the right, you'll be able to see where this thing about 10 to 1 is coming from. This is a particular alpha and has that result, but we don't really know how our investments are lying on the power law curves until we have really very many of them. So here is something which was done on the sample of very many investments of many VC funds and other investments for comparison. As you can see, the alpha is pretty close to 2, meaning no average. And also it is the bigger, more profitable, for the larger funds and larger investments. This has consequence if you try to invest. And why people do this? If you cannot really predict, which I'm trying to convince you about, why bother? And the reality is that the reason for investing is just this discrepancy between a distribution with defined average, which is the green curve, and much higher curve of the power law distribution with alpha close to 2, meaning there's very rare events where the profits are like 100 times or 1,000 times the initial investments is what attracts investors to the VC funds. Regretfully, the returns by the VCs are also governed by the power law distribution, meaning that average of 95% of VCs never return money to their investors. So it's extremely risky business. And the tactics at that stage should be governed by, sorry, I jumped to something, should be governed by the number of investments. You should divide your portfolio, you should divide your fund into the equal chunks because you cannot really tell, and then make as many investments as possible to be able to get into that region where there is a strong discrepancy between the curves. How it all relates to the 5G. Actually, what I have shown so far is closely related to what you would be calling technical analysis for the stock-based investments. There are some rules, you can infer them. Here are the numbers, yet some of the areas are more successful than others, and that's beyond the numbers which I have just presented. Enters 5G. So from what I said, it looks like this is just a matter of chance. And I'll try now to convince you that for certain investments in the 5G world, VCs are essentially bound to make profits. Let me start with something else. I'll be going back to 80s. I know that most of the audience is not old enough to remember those. Just a short flashback from those times. The wireless communication was essentially invented by Marty Cooper back in 1973. The guy was employed at Motorola, my company since 2000. And by 1980, Motorola delivered a lot of those mobile phones. They were analog ones, obviously. And they were dubbed in the US as a car phones. You might see them on the movies from that period. And at the same time, they were strongly competing against the AT&T, for example. And yet another company, Telelocator. And in 1980, they made a prediction about the market size in 2000. And I'll give you some numbers, take note of them. I will be returning to them later. AT&T predicted that it will be something like 700,000 phones by mobile phones by 2000, by year 2000. Motorola was much more conservative, and by that time they knew more than anybody else about the mobile phones because they were essentially owning the market. Their prediction was 270K. And the Telelocator, if you never heard that name, that's okay. They died before the Wikipedia and Google search, so they are really difficult to find in the internet. However, if you know what the TAP file is, that's their invention. This is something which they invented as a set of protocols used to transmit the short message and images over those poor networks at that time. The TAP files I still remember working in AMS, American Management Systems, doing billing systems for large telecoms, and we exchanged data with other providers by the tap files. It outlived the existence of the telelocator, but that's their intention. So remember the numbers: AT&T 700,000, Motorola 270,000, and telelocator 350,000 phones, mobile phones by a year 2000. And what happened since was essentially the existing business model disruption. I would call that an unfair advantage to an incumbent in that market. Look what happened. In 1982, if memory serves me, AT&T was split into baby bells because of the government anti-monopoly action. Telelocator existed till mid-90s and died in the series of legal processes against the FCC and essentially the government of the US. Motorola survived till 2000, but what happened to all of them was a business model disruption. So I'm hearing what others said here about the future and the predictions and the areas and business models. I would claim that whoever tries to predict the market size, dividing into verticals and doing it today, might be in the position of Motorola or AT&T back in 1980. So I don't want to keep you in the dark any longer. By the year 2000, they were 109 million of the mobile phones in the US. This is something like 400 times bigger market than what the best in the field could have predicted 20 years back. And I think that we are exactly the same situation, with one exception. Nobody tries to make the prediction today for like 2034 market size, right? This is useless, and everybody knows that predicting beyond the singularity point coming from the new services which are enabled by the Open RAN. It's not so much by the 5G. 5G can be just implemented as a replacement to 4G and get you something like 20% of the improvements. Notably, people are willing to pay more for that. I did that analysis from 40 to 9%, and the average is something like 25%. People are willing to pay more for just the badge of 5G. But what's interesting in 5G for the VC is that it is a paradigm shift. And as it was mentioned in previous talks, essentially enabling more competition in the markets will create markets and services which we don't dream about today. So look what happened in the disruption, which disrupted Motorola, by the way, of the 3G introduction. I was part of that, so now I can speak from the experience. All the operators at that time wanted to create walled gardens. They thought that they will be selling the applications of their choice and with the appropriate pricing tag to their customers. Nothing could be further from truth, right? The 3G enabled a smartphone, and the smartphone broke the monopoly of carriers, despite the fact that it was coming pretty late. So I'm expecting that 5G can similarly disrupt the monopoly of incumbent telecom infrastructure. You've heard those buzzwords, right? The carrier-grade equipment, 5 nines availability, and other FUD strategies. I spent some time at Google, where when I was starting, rather than buying the expensive RAID, this, by the way, RAID mentions inexpensive. The I is for inexpensive. Never was truth. But Google built their servers from the off-the-shelf elements, and yet was able to provide uninterrupted service, which is crucial. So I think that the Open RAN is the true enabler of the disruption because of everything which was mentioned: slicing of the network, edge computing, breaking the loop via MSC to close the call. Everything which Open RAN does essentially enables a host of different services which we don't even dream of today. So that's the reason why, if we as a VC need to go against the odds and finding something which might be beneficial and provide the multiplies sufficient for us to give good returns to our investors, is the Open RAN. And the unfair advantage which we are always searching for in investing was caused essentially by President Trump, who was trying to exclude Huawei. At the same time, he didn't want to be explicitly targeting them. So the support for Open RAN adoption from the government on the second largest market was crucial. So for the Western world, the breakthrough will come from the Open RAN deployments, and that is helped very much in the last year or so by the government decisions. I would think that the pattern of the disruption is similar to what happened in the past, and that was the reason why we happily invested in ISN and trying to help them along the way. Thank you very much.
Thank you very much, Wojtek, for this insight from the investor perspective.
Thank you very much. And Wojtek from BAIT and Bitspiration Booster VC was our last speaker today. So thank you very much for being with us today. We hope you enjoyed it.
It's great to experience how Open RAN ecosystem is getting mature and how it is evolving. Today we've heard perspectives from both officials, from regulators, from mobile network operators, then from the suppliers, starting from hardware with a chipset, with servers, with remote radio heads, and on the software part, radio access network, edge virtualization, orchestration. So we really wanted to bring different players, and it's great to see the momentum behind Open RAN.
I would like to thank all speakers that joined us today. I would like to thank all participants who were watching the conference. Thank you for asking questions. And also a big thank you to all companies and institutions which helped us create this event today, especially the Chancellery of the Prime Minister of Poland, IBM, Deutsche Telekom, VMware, Aalborg University, Ofcom, Cable Free, Hewlett Packard Enterprise, Tambora Systems, Comarch, Marvell Technology, Bitspiration Booster VC, and also a big thank you to the beautiful venue we are in, the Central Technology House in Warsaw, Poland.
We are looking forward to creating 5G together with you and for you. Thank you for today.
Thank you very much.